Good morning, everyone, and welcome to IPF Virtual. We at the network are thrilled to have you joining us. Over the next 2 days, we'll be providing the time-sensitive content that you need to prepare your business strategy in the ever-evolving U.S. offshore wind sector. My name is Brandon Burke. I'm the Policy and Outreach Director for the Business Network, and I'll be your MC for the next 2 days. So before we get started with today's program, I have a couple logistical notes. First, all sessions of IPF Virtual are being recorded. A link to the recordings and presentation slides will be sent to the email address that you used to register. The audience will be kept on mute. Each 1-hour session will include 45 minutes of presentation and 15 minutes of Q&A. And should you have any questions for our panelists, please go ahead and type them into the chat box on your screen. And now, without further ado, I'd like to introduce the one and only CEO and President of the Business Network for Offshore Wind, Liz Burdock.
Hi, everyone. Welcome to IPF Virtual, and welcome to my home. Like so many of you around the country and around the world, I'm sheltered in place with my family, and I hope you and your family are safe and well. You know, this is a little weird talking into my computer video screen, and it's certainly not how I had envisioned opening the 2020 IPF, but I'm really glad that you decided to join us. I also recognize that this is an extremely challenging situation for all of us, but technology enables us to deliver one of the hallmarks of IPF to you, which is timely and valuable information right to your own home. I also recognize that the world has slowed down due to COVID-19, but the good news is that offshore wind keeps on moving forward in the United States. Just last week, Virginia's governor signed a piece of legislation that includes a 5,200 megawatt commitment of offshore wind. States have now committed to 29 gigawatts, and these commitments are codified into law, and they firmly establish our U.S. offshore wind market. And when you get a market, you also get regulations kicking in. And that's why we decided to deliver to you the content that you're going to be hearing over the next 2 days. Historically, BOEM and BESI have used the IPF to gain industry input into programs and policies and to solicit feedback. So although you might be listening from your home office or your own living room, I highly encourage you to use the platform to engage with the regulators. I also encourage you to use the virtual platform of WindMatch and your network membership to keep reaching out to those business partners and to create the strategic relationships that we are going to need to strengthen U.S. offshore wind supply chain. You know, in the United States, we have 11 projects that have received a state financial award. We also have 7 construction operations plans under review at BOEM. The world and our country are going to need those clean energy infrastructure projects to get our economies moving again, and we're going to need you. So in closing, I want to say thank you. Thank you for your flexibility, for your understanding, and thank you for your support. I also want to encourage you to keep reaching out and connecting with one another. I also want you to keep checking back in with the network to hear about the latest U.S. offshore wind developments, because things are happening. But most importantly, I want you to stay safe and well.
Once again, good morning, everyone, and thanks for joining us for the first ever IPF Virtual. I'd like to introduce our first workshop, which is called Offshore Wind, The Challenges Ahead. Our panelists will be addressing topics that impact the federal offshore wind energy program, including leasing activities, the pace of state procurements, and offshore transmission. So please join me in welcoming our moderator, James Bennett, Chief of the Office of Renewable Energy Programs at the Bureau of Ocean Energy Management. And let's also welcome our panelists, Bill White, President and CEO of ENBW North America, John Dalton, President of Power Advisory, and Eric Hines, Director of the Offshore Wind Energy Graduate Program at Tufts University. With that, Jim, please take it away.
Well, thank you, Brandon, and thank you especially to Liz and the Business Network for making this making the best of this current situation. I hope everybody on the webinar and their loved ones are doing well, and as we work through this current challenge. This panel is also about challenges that face the development of offshore wind energy here in the United States. The demand for offshore wind energy has never been greater. It promises to be a major part of a diversified national energy complex. Hopefully the slides are up and you're seeing the Atlantic region with the areas that we have leased and areas that we are looking at. We now have 16, the Department of the Interior, through the Bureau of Ocean Energy Management, or BOEM, has issued 16 leases for offshore wind development. But leasing alone is not enough. State leadership, as exemplified by the Block Island project, and also demonstrated by aggressive renewable energy goals with specific offshore wind targets, followed by authorizations for offtake, about half of which have been already awarded. These efforts have combined with federal leasing, and it has created a tremendous market opportunity. So where are we right now? Aside from the lease sales that we've completed and the 16 leases we've issued, we've approved site assessment plans and a general activities plan for CVOW off of Virginia. But the key thing right now is that we're reviewing 7 construction and operations plans. And we anticipate that in the coming year, we'll have up to another 5 COPs to work with. Aside from guidance, we have leasing 5 areas: Gulf of Maine, the Carolinas, California, and Hawaii, and of course the New York Bight under consideration for additional leasing. With all of this activity, we anticipate that with steel in the water starting this year on the Outer Continental Shelf with the Virginia project, we anticipate that the coming decade is going to see 12, 15, or even more projects on the East Coast to address some of the demands that we are facing. To be sure, we're facing immediate challenges keeping up with plan approvals and permitting and ensuring that robust, informative environmental analysis is in place. But we are also facing larger, more long-term challenges to the well-being of this component of our energy mix. Questions like how much leasing is enough, will procurements keep pace with demand and industrial capability, and will offshore transmission issues and costs stifle the development of the industry. With insights from the key experts on the panel here today, we're going to highlight some constructive approaches to address these challenges that will have profound impacts on the future of this developing industry. With that, I'd like to introduce Bill White of ENBW. Bill has been very successful and very influential in the development of the U.S. offshore wind. As a graduate of Boston College and Harvard, he's been a special assistant at the White House and with the U.S. State Department. Bill led the Massachusetts state efforts to help define the federal leasing process. He's been a key leader in the 10-year effort to develop a Massachusetts offshore wind market. And with that, Bill, I'd like to hear your perspective on leasing.
Great, Jim, thanks very much. Appreciate the introduction. Hope everyone is well. I hope most of you are still in your pajamas. I decided to shake it up this morning by wearing a tie. As you can see, I got my Red Sox tie. Some of you may not know this, but the Sox are undefeated this year. So let's dive into our favorite subject of offshore wind, and very much looking forward to the discussion, and thanks for Thanks for joining. So just a quick note about EnBW. We are the subsidiary of one of the leading German utilities and offshore wind pioneers. We built the first offshore wind project in the Baltic Sea in Germany, have two projects completed there and two projects recently completed in the North Sea, and are excited about moving forward kind of the industry's largest and zero subsidy offshore wind project known as Hydrite, a 900 megawatt project moving to contracting in the months ahead. I will dive into the kind of the subject matter, our topic, which is really new lease areas. I'm told that other than the IRS, the Bureau of Ocean Energy Management is the largest generator of revenue in the federal government. And so, at a time where the federal government is spending an awful lot of cash out the door, wouldn't it be nice for them to kind of, bring in some more revenue? That's what offshore wind leasing does. Obviously, new lease areas are going to create greater economic activity throughout the supply chain and create new jobs. And really, most importantly, offshore wind leasing areas will increase competition in the state offshore wind solicitations that are undergoing now. Why more competition? It's really just basic economics and supply and demand. It will drive all of us as developers to basically to propose the very best projects we can. It will enable states choice and let them select what is the projects that best meet their needs. And of course, it goes without saying that competition is likely to drive down costs and costs for ratepayers. We believe that more competition will be good for the supply chain. And again, I think no one wants to see a monopoly form in this industry. All right, so this is a map that many of you are familiar with. Just to take a quick second to align and provide a little bit of context there. So there is kind of the close-up of the New York Bight, or really of the Northeast, but I'm going to focus on the New York Bight, New York, New Jersey Bight. And, I'm just going to take an example about why we need more lease areas. So this is coming into 2018. New Jersey, as you all know, the great Governor Murphy has put together a pretty ambitious program. And so they began their first set of procurements back in 2018. You can see that, the green areas that Jim referred to, the future areas of offshore wind leases are not, I guess, in existence. Our federal friends have not done an auction yet there. So really, New Jersey only has 3 developers that can bid into their auctions. In 2018, they had Empire Wind, the Equinor team up there into the north. And again, I broke it out to kind of 2 kind of project areas. So 1 lease area and 2 project areas within the Equinor lease area. Further down to the south, you see the Atlantic Shores project, which is the team of Shell and EDF. And of course, to the south is the Ørsted Ocean Wind team. So that was going into 2018. You had, again, 3 developers bidding into the New Jersey procurement. So what happened? In 2018, we all know that Ørsted's Ocean Wind project, 1,100 megawatts, did win the New Jersey procurement. So, good for them. Congratulations. But you'll also notice on the north, the Equinor team won a procurement into New York. So moving into a procurement later on this year, New Jersey wants to try to do another procurement. As they move into it, they really have, yes, the potential of 3 developers bidding into the New Jersey procurement in 2020, but really only 4 project areas. So we're having a more constricted market, as we move forward. So again, I'm not predicting the future here, but maybe just as an example to kind of explain where we go in 2022. So after the 2020 auction, again, this is a bit of a leap of faith here, but I think, there's various scenarios, but, here we move to 2022, right? And what I would say to you all is that, if you look at that Atlantic Shores area, the middle area with the 2 red circles, let's say, for sake of argument, that our friends at Shell and EDF do win the next New Jersey procurement for 1,200 megawatts. Okay, let's just say that happens. Let's also say, though, they win a New York procurement in 2020 And then possibly what happens if Equinor also wins a New York procurement? New York awarded 2 projects last time. Who knows what they're going to do this time? It's theoretically possible, or actually I would say quite likely possible, that in 2022, there possibly could be just one project that could compete into that New Jersey solicitation for 1,200 megawatts. And that would either just be Ørsted, or possibly it could be just Shell if Ørsted wins the next New Jersey procurement. So again, I don't want to make any of my friendly competitors frustrated, but this is really just to kind of visually demonstrate, the very real likelihood that in 2022, the great state of New Jersey might really only have one bidder in that coming procurement. So let's just maybe just kind of drop down a little bit more. So, the argument that I make is, up and through 2022, you have a continually restricted market that is eligible to bid into the New Jersey procurement. And I would also argue that in 2024, 26, and 28, you see the numbers, you see New Jersey, there will be no bidders enabled to compete into those future procurements without additional offshore wind lease areas. So our current projections is that, indicate that 2022 will be New Jersey's last competitive solicitation this year. And that likely moving forward, New Jersey could fall about almost more than half of their goal not being met. So again, I think it's kind of trying to demonstrate kind of the urgency for our friends, my friend Jim Bennett and his team at the Department of Interior in BOEM, to really kind of advocate and move forward this leasing process sooner rather than later. And let me just do one kind of closing slide. We're all thinking about this just incredible and unique crisis that we're all in. We'll probably be talking about it for generations, much like our parents and grandparents talked about the Depression or World War II here in the U.S. But, as we think about this economic recovery, which is going to come, we do not know when. Public health obviously being, the main determinant about our recovery. But, at least, we see a real significant opportunity that the Department of Interior and BOEM can play in helping to kind of relaunch this economy in the months ahead. And that is by, with existing authority, really kind of move forward this offshore wind industry. We are pretty much kind of right on the cusp of launching. We obviously need our federal partners to be with us. And so, there's 3 kind of almost no cost initiatives that our friends at Interior and BOEM could move forward that would unlock, really unleash this offshore wind opportunity. These are multi-billion-dollar projects. When they're constructed, they'll be among the largest construction projects in the United States, and they will mobilize thousands of workers. So again, moving forward, the contracted projects, the projects that already have PPAs and ORECs, in Vineyard Wind, of course, Empire Wind, Mayflower, Park City, Sunrise, and of course, the Maryland projects. We think it is urgent for our federal partners to move forward the leasing process in the New York Bight. Again, we were originally anticipating this to happen a year or 2 ago, but again, we are patiently waiting. There's been mention of the California offshore wind opportunity. Again, we know there are important issues, but we believe that should be a sense of urgency moving forward. And I was also very pleased to hear Jim talk about the importance of also moving forward additional lease areas. And just think for one moment, who would have thought that we would actually have this much offshore wind demand along the East Coast, just on the East Coast? But think about it. When we move to electrify the transportation sector, when we move to electrify the building sector, it is quite likely we're going to need more offshore wind, not less. So anyways, with that, I'll take a break and maybe turn it back to the great Jim Bennett.
Thank you, Bill. I have a quick question for you, but I want to note that at the end of the presentations, we're going to go back to Brandon so that we have plenty of time to get questions from participants. But Bill, there's a lot of estimates out there about the current or future potential capacity for the wind energy development in the areas under the existing 16 East Coast leases. Some estimates have even maintained that the 16 leases alone will accommodate more than the total demand that's been identified by the states. Now, you've used New Jersey as an example of the need for additional areas for leasing. But if it is the case that we can satisfy demand with existing leases, what's the justification for pursuing additional leasing? And what I'd really like to know is whether you believe that the situation you've described in New Jersey applies more generally on the East Coast.
So thank you, Jim, for the question. I think the answer is yes. The situation does for New Jersey. I chose New Jersey as just one example, but you could easily make that same argument for for New York. You know, with the 9 gigawatt offshore wind target, the largest in the country, there is not currently enough lease areas to meet that 9 gigawatt goal. Never mind the idea of competition. You could look at this great state of Virginia moving at 5.2 gigawatts. You know, right now Virginia really only has two potential bidders that could compete into that market: the Dominion area as well as the Kitty Hawk and Avangrid site. So you really only have 2 bidders competing into a procurement process, which again, you know, and one other point is that not all lease areas are developable. We're going to have important issues with stakeholders. We're going to have to make accommodations. We're going to have to shrink areas, and so. But I think the state of the industry is very, very clear. Without additional lease areas that not only provide an ability to meet these state targets, but do so in a competitive fashion, I don't think we're going to be able to build this industry forward as we all need and hope. Thanks very much.
Okay. Well, thank you, Bill. We appreciate it. Let's move on to procurement. I'd like to introduce John Dalton. John has had major roles in over 25 electricity procurement processes, including working with Rhode Island and NYSERDA on their offshore wind procurements. With degrees from Brown University in economics and an MBA from Boston University, he's focused on evaluating electrical system investments and utility resource planning. He's currently advising the province of Nova Scotia on a procurement process for a tidal energy demonstration project. Can you give us your thoughts, John, on procurement issues?
Certainly. Thank you, Jim, and to the Business Network for the opportunity to share some of my insights on competitive procurement for offshore wind. My focus is going to be on the recent competitive procurements, starting with the Massachusetts 83C RFP, where bids were due in December 2017, and an award was made in May, 6 months later, 2018. What we have here is essentially real levelized prices. These are prices which escalate with inflation. We've brought these all back to $22. And you can see on the x-axis, we have the project and service dates. And on the y-axis, the prices in terms of dollars per megawatt hour. I'd like to make a couple observations in terms of what we're seeing on this figure. And first, we're talking here in terms of competitive procurement. I think it's important to recognize that price is the preeminent evaluation criteria in the vast majority of competitive procurements for electricity resources. In the Massachusetts, Connecticut, and Rhode Island RFPs, price represents 75% of the total points. In contrast, in the New York RFP, it represents 70% of the total points, still the vast majority of points. So a couple observations in terms of what we're seeing in this slide. It's pretty clear that it looks like the Southern New England RFPs, and when I'm talking Southern New England, I'm talking about Massachusetts, Connecticut, Rhode Island, have been able to realize lower real levelized prices. A couple factors here. I think one thing that's important to remember to recognize is that there is marginally better wind resource that's available in the Massachusetts and Massachusetts Rhode Island wind energy areas, and that's a benefit that's realized in these Southern New England procurement processes. The second fact is the fact that the Massachusetts, Connecticut, and Rhode Island RFPs, as I indicated earlier, typically have 75% of their total points are focused on price. And in contrast, the NYSERDA RFP, as I mentioned, has 70%. So it's a marginal difference here in terms of the weight that's given to price. But importantly, the NYSERDA RFP does allocate 20% of its points to economic benefits. The Southern New England RFPs consider economic benefits, but it's only one element of a multitude of considerations that are reflected in qualitative considerations. So NYSERDA in New York State has deliberately made a decision to recognize that one of the drivers for offshore wind for offshore wind is the realization of these economic development benefits. And they've been very transparent in terms of their RFP process and elected to assign 20% of the total points to these economic benefits. So what this means essentially is a bidder who's participating in the NYSERDA RFPs is more likely to kind of be in a position where it can make explicit trade-offs in terms of price versus delivering greater economic development benefits to the state of New York. And I think that we're seeing that in terms of the results of the process. Recall that the Empire Wind, one of the proposals that was selected in the first NYSERDA RFP, is proposing to build gravity-based foundations in the Port of Coymans in New York. So that's a clear effort where they've decided that they're going to give some weight and appropriate consideration to economic benefits. Moving on, some other factors that can explain these price benefits. I've obviously talked about the relative weight given to price versus economic benefits. I've talked about differences in terms of the underlying wind resources. Another important consideration is the investment tax credit. We see this, the Vineyard Wind project, which had among the most aggressive project development schedules, was given their assumption of their in-service date, was able to take credit for a higher realization of the investment tax credit. So that's one thing that essentially allows them to potentially offer a lower price. There's other important differences. One I think that I'd like to stress is essentially the competitive dynamics. And we see this, it's often measured in terms of the number of bidders and the number of proponents that are likely to be responding to an RFP. And this is, the same type of logic that Bill White just referred to. And while in the Massachusetts RFPs, there were only 3 bidders, I think that we saw bidders who were very focused in terms of securing either a first mover advantage in the case of Vineyard Wind, or the Mayflower proposal, which was very focused in terms of establishing kind of so to speak, a beachfront in a position from which they can secure success in terms of subsequent RFP processes. This next slide presents a upcoming procurement schedule by year, focusing on the Northeast states. As you can see here, we've got Maryland, Connecticut, Massachusetts, New Jersey, and New York. For those states where it's colored in, and it isn't in an outline form, it's based on the identified, relatively known date of the procurement process. Where it's in outline form, it's based on our best guess in terms of when the RFP process is going to be initiated. One thing to highlight here is the NYSERDA OREC RFP for 2020. And you can see here that it has both solid as well as an outline. And this interestingly reflects NYSERDA's perspective, which was outlined in their filing with the New York Public Service Commission, where they basically made the case that it's their view that the competitive dynamics in near-term RFPs are going to be more compelling and are going to yield lower prices or offer the likelihood of realizing lower prices, given the fact that there are more bidders with greater volumes of lease area that are able to participate in these near-term RFPs. This, along with the extension of the investment tax credit in 2019 for projects that go into construction in 2020, are kind of cornerstones of their argument that they would like to have an incremental procurement authority of up to 2,500 megawatts. So they're expecting to procure at least 1,000 megawatts, but might elect to procure as much as 2,500 megawatts based on these underlying market dynamics. It's interesting in that, from our perspective, this is a real change in terms of how the market views pricing with respect to offshore wind. I think that initially people were of the view that as the supply chain matures, as the market has greater comfort with respect to offshore wind procurement processes, it's reasonable to expect, it's reasonable to expect that you would get decreasing prices over time. This was in fact embedded in the Massachusetts enabling legislation, which effectively mandates that subsequent procurements realize lower prices for contracts to be awarded. This condition was waived in the most recent Massachusetts RFP, but nonetheless, Mayflower Wind was able to deliver a lower price than the Vineyard Wind proposal. Finally, I feel like it's important to reflect in terms of the impact of COVID-19 in terms of procurement processes, and as well as the development of the supply chain. You know, one risk here is delays in procurement processes, and we could see kind of near-term delays in procurements. We, as Jim indicated, we're administering an RFP process for the province of Nova Scotia for tidal energy resources. We elected to essentially cancel that process given COVID-19 and the challenges associated with tidal energy developers, which aren't as well capitalized as offshore wind developers. There are challenges in terms of being able to deliver on commitments that were made before COVID-19 became the pandemic that it now is. I think one point of contrast is we're seeing that NYSERDA, with respect to their RFP for land-based resources, their RES RFP, NYSERDA has elected to not delay that RFP, so they're largely going forward in terms of their schedule. So that's some suggestion that for better capitalized developers or resources where developers typically have more financial capability, there's less need for delays in procurement. There is the risk in terms of delays in the supply chain. Our expectation is that there are going to be some potential challenges in terms of the construction season in Europe this year, and there's potentially will be some knock-on effects for 2021. Not sure in terms of what are the potential implications in terms of slowing regulatory approvals. That's obviously a critical issue in terms of the development of the industry. And then finally, just financing impacts we expect to be relatively limited given the financial capability of most offshore wind participants. And with that, look forward to any subsequent questions you might have. Thank you.
Thank you, John. This is Jim. I'm sure we're going to have some questions for you, but in the interest of time, I think we're going to have to move along so that we have Q&A opportunity at the end. I'd like to introduce Eric Hines, who's going to talk to us about transmission. Eric focuses on engineering solutions for the offshore wind industry with degrees from Princeton and University of California, San Diego in applied mechanics and structural engineering. He's received several awards for innovative infrastructure designs, and he's been involved in large-scale testing for facilities from Charlestown, Massachusetts, to Beijing, to San Francisco Bay, and right here at the Block Island Wind Farm. Eric currently directs the Offshore Wind Energy Graduate Program at Tufts University, focusing on infrastructure development, such as transmission for the offshore wind industry. And with that, I'm going to turn it over to you, Eric.
Okay, thank you, Jim. It's a pleasure to be here. And I'm really happy to have the opportunity to talk about transmission in the context of infrastructure. What we are on the cusp of, as Bill mentioned earlier, is essentially going to become the most major infrastructure build out in our country's history if this whole industry keeps going in the direction that it's going, and we are on track to meet our 2050 goals. So I think the name of the game is scale. And just to review a few things that everyone knows, but to again stress how quickly all of this has happened, where we are in 2019 with plans to move forward with 12 megawatt wind turbines that are taller than Boston's Hancock Tower. When we think about just 3 years ago, Brayton Point closed down and retired amidst numerous other fossil fuel power plants in the New England area. This was really what made clear to the Massachusetts legislators that we needed to move forward with major utility scale procurements. If we think about transmission, we think about the complexity of all of this. We really get to the heart of a lot of the questions of governance, of regional, of state governance versus federal. What's the role of the federal? What's the role of the markets? What is the role of the regions? And we also see at the same time this real strong movement forward on land-based wind. We can see the headlines from the last couple of years in terms of how much land-based wind there's been in the Southwest Power Pool. We can also see, if we take a look at the queue for ISO New England, that you can see that projected offshore wind is listed in blue, how that has grown from 2016 to 2020. Over time, and how in New England land-based wind has become less and less of the preferred option. So this is all happening in real time. I would just want to present two scenarios. These are essentially conceptual scenarios that we've been working on, but one is a scenario of the offshore areas, Massachusetts and Rhode Island, New England area, talking about what this might look like with a generator lead line approach. That's scenario one. Scenario two is a scenario that we've imagined with a networked approach, but also drawing in existing generator lead lines for projects that already have been procured and are planned as such. And the interest that we have here is in reliability. As we move more and more of the electricity to the grid, right now we're talking about 30 gigawatts, but if we start talking on the scale of 2050, it would not be at all strange to start talking about 300 gigawatts, somewhere in the hundreds of gigawatts. And the need to ultimately connect an offshore wind transmission system to have a North Star that we're focusing on that really gets our market-based approach to this incremental approach, thinking about the big picture as well as the incremental learning that we do on a project-by-project basis. So I want to talk also a little bit about, we've been here before recently in New England when we were thinking about land-based wind. The idea of a backbone loop is not strange. In 2009, the New England governors were talking about 12,000 megawatts of land-based wind plus offshore wind. Now we're talking about 12,000 megawatts of offshore wind. We can also see that a lot of our thinking about the modern grid and a lot of the 345 kV lines in New England, really, in a lot of our ISOs and modern reliability councils date back to the blackout of 1965 and to experiencing these rare but very impactful large-scale events. And so this is what drives us. This is what drives the concepts of reliability and resiliency and our need for a system. It's times like now, we're in the middle of this pandemic. This doesn't happen every year, but these are the things that we have to pay attention to in terms of thinking about the long term and about infrastructure. So just to talk about the national grid infrastructure here for a second, we can see these are the different interconnections and these are the different reliability councils. And if you lay on top of this the ISOs, we can see that the ISOs and the reliability councils do not superimpose perfectly on one another. And so this question of thinking regionally is an absolutely necessary question. The question of how the federal government and the state governments interact and talk to one another is absolutely necessary and is exemplified in the way that we ensure reliability for our electricity networks. Now, it has also been absolutely necessary in terms of how BOEM has developed the offshore wind energy areas in federal waters. I just want to end on a story that happened some time ago when one of the last times that we did a major build out that was really driven on the federal level. The ideas for the Pacific Northwest Southwest intertie actually date back to the 1930s. But really there were big strides forward in the 1960s, and some of this required a binational agreement between the US and Canada called the Columbia River Treaty to be able to marshal energy and to use water resources that spanned both countries. And so we're not strangers to this. I want to talk a little bit about what's inside the red circle here. This is the Columbia River, one of the most gorgeous sites in the United States and also one of the most productive in terms of electricity. And we think about the Pacific Northwest and the production of electricity and how electricity generation prices are the least expensive in this area of the country because of the hydro that's been built and because of this infrastructure that was constructed a long time ago and needed to be connected between the Northwest and the Southwest in terms of building out these very large-scale transmission lines. So you can see here, as part of the Canada-U.S. agreement, the Columbia River goes up inside of Canada, and there are several dams inside of Canadian borders that are relevant here to the river and also have affected downstream United States developments. And so you can see the different sort of power production facilities. These are large numbers. They're on the scale of what we're talking about right now for offshore wind. And then you can also see how old all of these different dams are, that they're not 25 years old. They're 40 years old, they're 50 years old, they're up to 80 years old. And this is the kind of thing that we also need to be thinking about as we're thinking about infrastructure. If we build out an infrastructure for the next 25 years, by the time we get to 2050, we're going to be repowering all of this. And I think that we're on the cusp of this change between thinking about wind as machinery, as sort of a market-based approach to developing lots of machines, to developing an infrastructure that the public depends on. And so we're going to have to be thinking about both at the same time as we move forward. And I want to just end on this idea of infrastructure. These are the East Bay spans of the San Francisco-Oakland Bay Bridge project I worked on a little over 20 years ago. And this particular bridge, similar to a lot of our major bridges, this is one of the most heavily traveled bridges in the country, 280,000 vehicles a day. It was designed for a 150-year lifespan to resist a 1,500-year earthquake. So we do have a language for thinking long-term. We do have a language for all of this that gives us a frame. And I am interested in talking further with the offshore wind community and with BOEM and all of our partners about thinking what are our long-term goals and how do we set our course to get to 2050. Thank you very much, Jim.
Thank you, Eric. Appreciate it. I think we're roughly on time, and we're going to turn it back over to Brandon for Q&A. Brandon, I've got a couple if you don't have any queued up, but you probably have a whole bunch, so go for it.
Yep, I sure do. And we'll be taking questions from the audience. We've been receiving some questions from before IPF Virtual as well as through the chat function. Jim, the first question is for you. We've received a number of questions about the potential impacts of COVID-19 on the federal vineyard wind permitting process, as well as the federal offshore wind permitting process more broadly, and also the impacts of this situation on federal leasing. Could you comment on that?
Sure. The COVID-19 situation is certainly having its effect on just about all business processes everywhere. We are in a full telework arrangement right now, and we're continuing to work on according to the schedule that we have for Vineyard Wind. We don't anticipate any schedule slips just yet. A lot of it will depend on how things work out with COVID and whether we're able to have the stakeholder involvement at the level that we'd like to. But overall, we're on track and we're on schedule, and we're continuing on for Vineyard Wind and the other projects as well.
Great, Jim. Thanks. This question is for John Dalton. Has Massachusetts' decision to fund and pre-build an offshore wind port has that contributed to the low prices that we've seen for Vineyard Wind and Mayflower Wind? Why or why not?
It's really hard to tease that out, Brandon. I think it's a fair question. Massachusetts made a significant investment in terms of the New Bedford Marine Terminal. I think that's proving, that's offering benefits. Vineyard Wind obviously has a lease for that. It's my understanding that the New Bedford Marine Terminal, Bill probably knows this better than I, but can effectively really only support about 400 of the 800 megawatts of the Vineyard Wind project. So they have to go elsewhere looking for it. The Mayflower, I don't know what their expectations are in terms of specific port facilities, but I think that it's clear that there probably are benefits that are being realized by Massachusetts in terms of the investment that's been made.
Thanks, John. This question is for Eric Hines. Do you think the challenges that have been posed by the continued development of the COVID-19 situation will result in the development of new technologies that are applicable to the offshore wind industry in the United States?
When I think about technology development in the United States and where this is headed, I think about the momentum of the last couple of years in the market. I think that what's going on right now in COVID-19 has much stronger social implications. But I think that in terms of thinking about the development of American technology and bringing the US on board up to the state of the art really has to do with ongoing efforts by the DOE and by other federal agencies to repurpose our existing national facilities. We have several $1 billion in existing research assets that are in the middle of being repurposed. Before COVID-19, Congress was actually getting ready to pass a major wind energy R&D legislation. And so we're seeing really tremendous movements in Congress and the federal agencies mobilizing the United States. And I see the continued momentum there. And we're very excited about what our public officials are doing in that capacity to fund research.
Great, thanks, Eric. I have a question for Bill White now. Bill, as you were referencing before, we were wondering if you could discuss the implications of the ongoing federal leasing process in the New York Bight with respect to transmission implications. And secondly, whether you think that the future potential lease areas that have been outlined by the federal government are sufficient to reach our clean energy goals that East Coast states have set forth for 2050 and beyond.
Yeah, thanks, Brandon. On the subject of transmission, I mean, this is an issue that obviously we developers feel rather strongly about. I think there's general consensus that there's a real concern that we're a little bit of a chicken and the egg issue, and there's a lot of concern about slowing any of these processes down in order to wait for the potential of someone building a super grid for us to all magically interconnect offshore. We have said that as a company, I think we understand at a high level, maybe at an academic, intellectual level, the value of a super grid, and I think Eric's points are well taken. I think for us though, it's really about who's going to pay for it, who's going to build it, who's going to determine the technology, who's determining the interconnection, and so those are big, massive questions. I think they're solvable, but I think as we look at kind of the next sequence of events, I think we're focused on and maybe thinking investment on a super grid, but on land would be potentially more cost effective and easier to maintain. So we're kind of the view that we're urging the key stakeholders in this subject matter to think about a significant upgrade. And of course, New York is in the midst of an analysis on that subject right now. Brandon, what was the second question?
Second question is whether, assuming that the call areas that have been outlined along the East Coast are leased, which is a big assumption at this point in terms of the time frame, are we going to be able to achieve off of those delineated call areas combined with the already leased lease areas? Will we be able to reach East Coast states' clean energy goals? We have a combined U.S. goal along the East Coast of about 30 gigawatts by 2035 at this point.
Yeah, I think it is a very good question. And I think for those of us who have been crazy enough to be involved in the offshore industry for more than a decade, and many of them are on that screen right now, and I know many are listening, when we started in Massachusetts, we were pushing a 1.6 gigawatt total, and everybody said we were absolutely out of our mind. We were crazy. And said, come on, stop the foolishness. There's no way we're going to have, that much offshore wind need. And so, but as I mentioned, again, I'm hoping that my friend Jim Bennett and his team, move forward that New York Bight opportunity and do it quickly, because I do think those projects, those sites are absolutely critical to enable both New York and New Jersey to meet their needs. And I think we can't be thinking about just today. We have to think about the future. And again, and I believe this is going to happen, we are going to move our transportation sector to an electric sector. We are going to transform the transportation sector to a clean energy generation. I think we're going to do the same for buildings, et cetera. So and I'm happy that Jim is talking about offshore wind in the Gulf of Maine, down on the mid-Atlantic and in the southern parts of the country, and in California. We need to kind of move forward. We need to do it in a very thoughtful way. None of this is easy. We get that. But we believe that offshore wind can be a critical and can coexist with the commercial fishing industry.
Thanks, Bill, for that answer, and we will forgive you for being a Red Sox fan. But Jim, if you wanted to step in, you mentioned you had a couple questions. Why don't you go for it?
Sure. I'd like to address a question to Eric about transmission, because it's something that has come to the forefront in just the last couple of years, and before that, it wasn't even an issue that was spoken of, to my mind, or at least to my knowledge. But can you play out for us what a likely scenario will look like if we continue on the current path with the right-of-way for each leased area and a business as usual approach to connecting to the grid? If there's an alternative, what would that be? And what would the appropriate roles of the federal and state government be in that alternative?
Appreciate that question, Jim. And I appreciate what Bill is saying as well. And I think it offers an opportunity to clarify something. When folks talk about an offshore grid, there's not a distinction between an offshore grid and a land-based grid. Talking about an offshore grid and a land-based grid is the same thing. The question is how are we going to generate a whole bunch of power in the ocean and send it across the coastline onto the land? The biggest issues we have right now are with the points of interconnect. And if we go at the pace we're going right now, what's going to happen is the developers who have the leases are going to grab all the key points of interconnect, and this is really going to strangle the ability to get electricity onshore. And so the points of interconnect need to be understood and held as public assets. They also need to be understood and used appropriately within the market. But this is something that really has to be thought about deeply, because one of the big dangers we have is actually stopping up the grid. The other thing is, to Bill's point, that New Jersey may run out of capacity and not get their grid onshore. If we had interconnects between the existing offshore wind energy areas, then what you can imagine flows of electricity that are a lot more similar to our land-based grids, and certainly to this Northwest-Southwest intertie, which was not just a federal effort, but an effort between the feds and the states and several private entities. It was just as complex as the stuff that we're looking at right now. So I think, Jim, I think we've got to have a vision. I think that it's clear that we have to have a market where we're learning about this. We've also got to figure out, a lot of Massachusetts power is now going to New York and Rhode Island and Connecticut. So we're already sharing the power from all of these states. This is all happening dynamically and in real time. And we've got to be thinking about this in terms of a big picture. And so I think that we've seen similar thinking as we built out the Marine Commerce Terminal, as we were designing the Wind Technology Testing Center, building this existing infrastructure. If we fail to think in terms of the big picture, we wind up shortchanging ourselves in the long run.
Brandon, I've got one other for John, if we're good.
Yep, go ahead. We have about 3 minutes left.
Okay, yeah, let's close out with some concrete advice, John. Can you tell us, based on your experience, what differentiates an effective electricity procurement process from one that is not as effective? And what advice can you give? How can these lessons be employed in the offshore wind procurements that we'll be facing in the future?
Great question, Jim. I guess from my perspective, the most important thing in terms of a procurement process is transparency. You need to convey to the parties that are participating in the process, what are your objectives and how are you going to weigh these objectives? And I've spoken quite a bit in terms of the NYSERDA process. There they have a very high level of transparency. They allow bidders to kind of assess trade-offs. One of the interesting things, Massachusetts has had considerable success with respect to its procurement processes, but in its most recent RFP, the winning bidder, Mayflower, put forward 3 804 megawatt proposals. One was essentially their low-cost energy proposal, which, as the name implies, is all predicated in terms of delivering the lowest cost energy possible. Then they had a infrastructure and innovation proposal, and then they had a mass manufacturing proposal. It's pretty clear that they were having a difficult time assessing the trade-offs that the evaluators were going to make when scoring their bid. So to the degree that you can have a higher level of transparency to assess how proposals are going to be weighed, you can maximize the competitive tension in the process and allow all proponents to put forward proposals that they think are going to best serve customers. So those are my recommendations. And thank you for that question.
Thanks. Thank you, John. Brandon, I think we're out of time, but can we get some virtual applause for the panelists? They've done a great job. We appreciate it.
Yes. Thank you, Jim, and we'd like to thank you, Jim, as our moderator, as well as our panelists, Bill, John, and Eric, for sharing your insights about the development and progression of the federal government's offshore wind program. The network would also like to thank our IPF sponsors, specifically our 2020 host, the state of Rhode Island, and our IPF virtual partner, the law firm of Womble Bond Dickinson. Our next workshop will begin at 10:15 Eastern, and it's called Mandatory Annual Facility Self-Inspection and Structures Assessment Requirements for Offshore Wind Facilities on the Federal Outer Continental Shelf. Stay with us.
Thank you.
The email address that you use to register. If you have any questions for the panelists, please go ahead and type them into the chat box that you see on your screen during the course of the presentations. The network would like to thank all of our IPF sponsors, specifically our 2020 host, the state of Rhode Island, and our IPF virtual partner, the law firm of Womble Bond Dickinson. Now, I'd like to introduce the panelists for our second workshop, which is called Mandatory Annual Facility Self-Inspection and Structures Assessment Requirements for Offshore Wind Facilities on the Federal Outer Continental Shelf. On this panel, we have representatives from both the Bureau of Safety and Environmental Enforcement, or BSEE, and the Bureau of Ocean Energy Management, or BOEM. They'll be discussing the inspections, assessment, and reporting requirements that are found in 30 CFR 585. Please join me in welcoming Christy Land, who's a subsea production specialist with BSEE, Sid Falk, who's a senior structural engineer with BOEM, and Mark Kozak, a mechanical engineer with BSEE. Christy, over to you.
Thanks, and welcome. Thank you guys for joining us this morning for our panel on the mandatory annual facility self-inspection and structural assessment requirements for offshore wind facilities on the federal OCS. So today, what we'd like to cover with you is kind of our goals for the presentation, the different responsibilities of the federal regulators involved, take a look at the OCS renewable energy, kind of the current status, and then get into expectations for the annual self-inspections, the structural assessments, safety management systems, and then give you some additional things to think about. So our goal for today is to outline our ideas about what the self-inspection program and structural assessments should cover for offshore wind facilities. We also really want to use this to start a dialogue with the industry. Currently, BSEE and BOEM regulate the largest workforce in the world. We have a lot of experience with inspections and with structural assessments. And so we bring a lot of learn to the table from that experience. But we also realize that there's a lot of international experience. There's a lot of knowledge out there in the industry. And so we really want to integrate our experience with what is going on in that international knowledge. So we really like to focus on developing a robust inspection program and promoting industry data sharing using the best and proven methods out there, make sure that we ensure safety and environmental compliance. Again, we really want to use this presentation to open a dialogue about self-assessments and structural assessments, self-inspections and structural assessments. And we hope that at the IPF in August, when we can hopefully all get together again, to share some of the updates that we've made based on that feedback. So where does our authority come from? It comes from the Outer Continental Shelf Lands Act as amended in 2005. And that gives Bowman Bessie our authority to regulate the offshore renewable energy industry. The Secretary of Interior delegated the renewable energy program to BOEM, and until such time the ASLM determines that there's an increase in activity enough that justifies transferring the inspection and enforcement functions to Bessie. And that's what we're working on right now. So currently, Bessie consults with BOEM on functions related to operational safety, environmental compliance, inspections, and enforcement. So you might be asking, there's U.S. Coast Guard in there. They're one of our federal partners. Well, the U.S. Coast Guard is involved with regulations of various types of vessels that will support the construction, operation, maintenance of the renewable energy facilities. And then the next logical question is, well, what about OSHA? And in 2019, DOI, Department of Interior, put out a policy statement that preempted OSHA and stated that the Department of Interior will act as the principal federal regulator for enforcement, workplace safety and health for renewable energy facilities on the OCS. So right now, Bessie provides BOEM with input on decisions concerning engineering. So this is facility designs, fabrication, installation reviews, on approval of certified verification agent or CVA nominations, on safety management system requirements, oil spill preparedness, any type of incident reporting and investigation, environmental compliance, decommissioning, including all the cost estimates, and the development of a lot of the technical standards. So with BOEM support, Bessie is really leading the development of some of the offshore wind HSE guidelines, self-inspection guidelines, and the enforcement program. But any of the recommendations Bessie has will be given to BOEM, and BOEM right now will be the ones taking the official enforcement actions. So I know Jim in the earlier panel covered this a little bit, but just to give you an overview of where we are in the offshore renewable energy arena. Right now we have 16 active commercial leases in the Atlantic that cover about 1.7 million acres. There's planning activities going on off of Hawaii, California, New York, the Carolinas, and we're expecting our first installation of a commercial grade turbine on a research lease sometime this summer. We have 8 currently approved site assessment plans off the coast of 7 different states. There's 6 construction and operation plans being processed. And we're anticipating about another 4 to 6 in the next 12 months. So things are busy. And again, that's why we really want to start this dialogue now to make sure we're ready for everything. So at this point, I'm going to turn it over to my colleague, Sid, and he's going to talk about some of the facility self-inspections and structural assessment requirements.
All right. Thank you, Christy. And thanks everybody for being here virtually. As Christy said, my name is Sid Falk. I'm a senior structural engineer for renewable energy within BOEM, and I'm going to cover our self-inspection and assessment requirements, then talk a little bit about some best industry practices pertaining to those two subjects that we expect that industry would adhere to. So our subpart H, our inspection and assessment requirements are listed in subpart H, basically 30 CFR 585, sections 820, 821, 824, and 825. Sections 820 and 821 are pretty self-explanatory. 820 says that Department of Interior, BOEM and Bessie, will inspect your OCS facilities and any vessels engaged in authorized activities. 21 says we'll conduct both scheduled and unscheduled inspections, so we do not have to tell you we're coming. 824 and 825 is where I'm going to focus. 824 details our self-inspection plan and reporting requirements. And A25 details our structural assessments. Next slide, please. So slide 3 deals with BOEM's annual self-inspection requirements. Requirements, as stated in here, are pretty simple. You must develop a comprehensive annual self-inspection plan. It mustn't cover all of your installed facilities. Talks about, it has to tell us the type, extent, frequency of your structural inspections, mooring systems if you have a floating system. Has to cover your corrosion protection monitoring system, and you must retain those records for DOI inspection. The next must is you must submit an annual self-inspection report submitted by BOEM to BOEM by November 1st. It should have a list of all facilities inspected in the preceding 12 months, the type of inspections employed, and a summary of the inspection indicating what repairs, if any, were needed, and the overall structural condition of the facility. And that's the important part. So simply put, you must develop a self-inspection program for your facility. You must conduct self-inspections in accordance with that program. You must keep records of those inspections. You must make those records available to BOEM. We do, thankfully, define what your facility is at 30 CFR 585.112, and it's defined as structures, devices, appurtenances, cables, vessels, permanently or temporarily attached to the OCS. And then you must also submit a yearly summary report of all inspections that occur that year. I'd like to point out that our regs and the only standard we have cited in our regs do focus on structural inspections. We realize and believe that effective inspection programs must address all safety critical systems and components, including certain electrical components, HIV electrical equipment, fire protection equipment, climate assist, service lifts, cranes. There's a whole lot of other stuff out there that needs to be inspected other than the structural. Next slide, please. So that's the extent of the requirements. What I'm going to talk about now is, I guess, best industry practices that we expect the industry to follow. So, as stated, we'd like to hear feedback from you on what we present today, and we will take that into consideration and hopefully improve our inspection program. But some of the best industry practices are for the inspection programs is that the inspection program should be compiled and approved by a qualified engineer familiar with structural integrity aspects of the facility. Observations of facility operating and maintenance personnel should inform your program. It shouldn't be a static document. It should be living, breathing, and take into account what's going on out in the field. And then the inspection program should include some provisions and methodologies for ensuring safety after experiencing a design event. Design event could be an extreme storm, a hurricane. It could be an earthquake. There are many design events, and there should be provisions and methodologies for ensuring safety after experiencing one. And once again, I just want to highlight, it's more than structural inspections. It's inspections of safety critical systems. Next slide, please. Now, your individual surveys. Individual surveys should be planned for qualified personnel possessing survey experience and technical expertise commensurate with the level of surveys performed. It sounds like common sense, but in our experience, it needs to be stated. Personnel conducting above water areas should know how and where to look for damage in situations that could lead for damage. Cathodic protection surveys and visual inspections of the underwater portion of a platform should be conducted by ROV or divers under supervision of personnel experienced with the methods employed. And non-destructive examination and testing, or NDT, of the platforms will be performed similarly by trained personnel. Next slide. Some more bullet notes, but for smaller wind farms, it may be feasible to inspect the entirety of each wind farm, each turbine each year. For larger wind farms, it's not necessarily feasible. So inspection programs designed from risk-based inspection planning are allowable. In many wind farms, or in wind farms with many series manufactured identical or almost identical elements, it may suffice to carry out inspections on a representative number of structures. And this is something I want to point out, in wind farm with non-identical elements, each element type will be included in its own risk-based inspection program. And what that's pointing at is there may be projects, large projects with multiple support structure configurations, and each one should be included in its own risk-based inspection analysis. Next slide, please. So that brings us to some more points. The periodic inspection consists of visual inspections, close visual inspection, or non-destructive testing, and testing of safety-related systems. The interval between inspections of critical items should not exceed 1 year. For less critical items, longer intervals are acceptable, and the entire wind farm should be inspected at least once during a 5-year period. Please, next slide. And so we talked about above water and NDT, different inspection types, and I wanted to point out the API RP2A WSD Section 14 does a good job of describing our structural inspections, and it basically breaks down into 4 different levels of inspection: 1, 2, 3, and 4. With level 1 being just an above water visual inspection, which you're focusing on identifying damage, checking the coatings and the cathodic protection systems. This is a yearly type survey, and you would add your critical systems checks would be included for offshore wind turbines under this industry. Level 2 is a underwater visual survey. Again, looking for damage, corrosion, but also scour, debris, and marine growth, and a visual survey of the cathodic protection system. These are performed by diver or ROV. And in layman's term, it's on a jacket structure, they call it a swim through. You send the diver through, he actually swims all around the platform, documenting it with video and snapshots, the general condition of structure. A level 3 survey was referenced as a close visual inspection on the previous slide, and it's a diver only, and it calls for the diver to go down, actually clean off the structure to get a view of the underlying substrate. It would take off any marine growth or remove anything that might obstruct their visual inspection of the joints. Our main area of concern is generally, the welded joints of the structure. Engineers should be used to pre-select the joints in question based on the modeled analysis, and they can identify areas of the highest loading and therefore highest propensity for damage. This inspection could become the basis for a level 4 inspection, and level 4 inspections on the next slide. Level 4 inspection is an underwater non-destructive testing of known or probable damage. And it's, again, use the engineers to predict the most highly loaded joints and send the divers down. They would do a cleaning of the area like on the close visual survey, but then instead of just doing a visual survey, they would use a mag particle or UT radiography or ultrasonic testing, and actually look for micro cracks, micro fissures, the beginnings of a crack. It's much more intrusive, but you get much better data from it, obviously. And so if they do note damage, dents, cracks, separations, the divers obviously document it pictorially, but they also do a detailed inspection of the damage area. They measure, draw a sketch, a diagram, and they report this back to the engineers for analysis and mitigations. And just the recommended survey within the API RP2A on these for L1 structures is yearly on the top side, 3 to 5 year interval for level 2, 5 to 10 year interval for level 3, and level 4s are as needed. Level 4s are resulted from a 3 inspection or it could be under governmental mandate, or it could be as a result as part of an assessment, which we'll get to now. Next slide. So quickly, what are assessments and when must I assess my facilities? Again, 585-825 says you must perform an assessment of the structures when needed based on a platform initiators listed in section 17 of WASD, API RP2A WSD 22nd edition. It says you must initiate mitigation actions for structures that do not pass those assessments, and you must perform other assessments as required by BOEM. Next slide, please. So that's the requirements. These are the initiators as listed in the API document. There's essentially 6 of them. Additional personnel, additional facilities, increased loading on structures, inadequate deck height, damage, founder inspections, and regulatory requirement. The first 2, additional personnel and facilities, I don't anticipate these coming into play in the on the offshore turbines, but they would if you went from a non-manned to a manned status, or if you were to increase large petroleum storage on a structure, it would change the risk profile. And the risk profile is the underpinning for our entire design. Target structural reliability levels are set with an eye towards our perceived risk, and if you increase this perceived risk, well, we may have to re-examine our target reliability levels. Increased loading on structures might come into play if you're looking to repower. If you're putting a new, larger turbine on there, you can have a larger swept area, and you would be adding loading on the structure. So it would have to include an assessment, including even if you're not repowering at life extension, the life extension would include an assessment. Inadequate deck height probably won't come into play, but should somehow your ESP, which would more than likely be a jacket type structure, subside over time, that could be problematic for its reliability and survivability levels. So we would want an assessment at that point. And then, as said before, presence of damage would trigger an assessment, and then regulatory requirement. Say, for instance, if you experience a design event. So, next slide, please. So, what are assessments? They're a system of inspection, testing, and analysis, which are designed to determine the structure's current condition. So the inspections include topside, underwater testing, could be condition monitor on the structure before, during, and after the event, could be non-destructive testing during the inspection process, and could be systems tests. The analysis part, assess your site-specific environmental conditions, model your structural loads under the revised conditions, and compare your utilization rates and any reserve strengths to see if you expect to experience problems in your structure. Next slide. I figure the best way to describe the assessment is to give you an example procedure. So this would be an example assessment procedure after the passage of a storm. And your first steps would be, assessment of the environmental conditions and comparison of what you experienced to the design conditions. Assessment of your control and safety system functions. This should be done remotely from your shore base. Load and response measurements, if available. That's if you're monitoring your structure through the event. Load calculations based on your, as said earlier, calculate your loads based on your experienced conditions. Review past maintenance inspection reports and field experience. Take that into consideration. Then you develop a turbine-specific inspection plan. And once you have that inspection plan, you go out and inspect per that plan. You would conduct visual inspection and possible testing of all load transfer and safety-related components, underwater inspections for damage, debris, erosion, cathodic protection system, non-destructive testing, etc. Performance tests, your SCADA system, yaw and pitch systems, electrical, and all safety systems. You compile an inspection report return that to the engineers for analysis and potential mitigation should based on the findings. Next slide. And lastly, we have just an example of some of the structural and safety related systems that have been mentioning throughout the slides, but haven't listed. Yeah, the tower system is fairly straightforward. Ladders, lifts, fall protection. Your bolted connections after extreme events would require testing for proper torquing, because they are designed to work under a a specific torque levels, and if your loads have been exceeded, you should go back and test those torques, retorque them. Your yaw bearing, gear, connection at the tower, and the nacelle cover, or some items within and around the nacelle. And then safety systems, specifically, like to call out the rotor yaw lock systems, the mechanical brake, vibration and overspeed systems, short service protection, collision avoidance, which is on the outside and is likely to be impacted, your SCADA system, and you can pretty much count on your anemometers and wind vanes being gone, so replace them. But with that, I think I'm going to turn it over to Mark to talk about the SMS.
All right, thanks, Sid. Good morning, everyone, or afternoon, depending on where you're dialing in from. All right, I'm going to start off by briefly talking about how the SMS ties into self-inspections. Most of you are probably familiar with what a safety management system is. Many of you may even have seen DOI's previous briefings on the subject, so I won't spend a lot of time on it. But essentially, it's a living document or a constantly evolving method of identifying your hazards and risks to your personnel and the environment and your ways of mitigating them, managing them. It needs to cover both occupational and process safety throughout the life of the facility. The main point that we wanted to stress today about the SMS is that it needs to align with your self-inspection plan and your design basis. They all need to tie together. The SMS needs to address the safety of all activities on your facilities, including your inspection activities. Next slide, please. So how does the SMS influence a self-inspection plan or vice versa? Well, audits are the usual mechanism for testing the effectiveness of an SMS. And while inspections tend to focus on equipment, like a physical inspection to ensure proper functionality, SMS audits tend to evaluate organizational elements, communication, procedural elements. Those are the things that influence the whys and the whens and how the equipment is operated and maintained. So physical inspections can help identify organizational gaps that can ultimately cause equipment failures or other unidentified risks, while the SMS can identify the management system weaknesses that can cause the same type of equipment failures or injuries. So for example, if an inspection uncovers a piece of inoperable safety-related equipment or other unsafe conditions, an inspector can shut down operations until it's fixed. But he or she also needs to ask the right questions to determine what led to that failure, which could influence or trigger an SMS audit. And on the flip side, if an SMS auditor uncovers a weakness in the effectiveness of the management system tools, they need to be relayed to the inspection teams so they can be more diligent in their review of the specific equipment. Again, the main point that we're trying to stress is that the SMS should align with your self-inspection plan. Next slide, please. So for our final slides, we just wanted to wrap everything up and run through some of our thinking, some things for you to consider for your self-inspection plans. We're not here to tell you what must be in the self-inspection plan or how to conduct inspections. They should be tailored to your specific operations, your company's way of business. We want you to develop what works best, what's most efficient, and what makes the most sense for your operations. We envision it being some combination of internal staff, third-party inspectors, OEM inspections, whatever gets the right people looking at the equipment when it needs it. It can and probably should be a mixture of physical inspections and remote inspections and use monitored data to the fullest extent practical. We also envision that to some degree, self-inspection plans will take a risk-based approach to integrity management. I use that term loosely. Risk-based can mean different things to different people, but all we really mean is that the offshore wind operation can and probably should use some form of focused inspections or risk-based inspections to manage their assets. Some equipment may need inspected and may not need inspected every single year on every single turbine, but certain turbines, it may be necessary to inspect that equipment twice a year due to its placement in the wind farm, loading, other environmental factors, and so on. So again, it allows for the flexibility to inspect what needs inspected and when it needs it. It's not just a check in the box. We want to avoid complacency from the start. Next slide, please. So your self-inspection plans. You can include as much information in your self-inspection plan as you think is necessary to demonstrate that you're providing the appropriate level of safety to your workers and the environment, like inspection processes for critical safety equipment and systems, applicable industry standards you're using, OEM recommended inspection cycles, adherence to it or separation from it, and reasoning why, and your methods of tracking it all. When there's more information included in the self-inspection reports, the more confidence we have in your inspection program, which may ultimately help decrease the need for DOI physical inspections, our need to go offshore to your facilities. We recognize that there's risk involved with sending people offshore, and we don't want more people offshore than is absolutely necessary to get the job done. Within DOI, we plan on hiring engineers to review the SMS audits, the self-inspection reports, to look at the data. We want to build a better, smarter inspection program from the ground up that fits this industry. Next slide, please. So ultimately, it's the responsibility for the inspection and certification of the facilities. And the DOI regulations allow for the flexibility to establish and implement what works best for you. We as an agency are just starting to develop our compliance assurance strategy. We have our ideas of what we think the self-inspection should cover, and we have a lot of past experience that we're bringing to the table from the oil and gas industry. But we also want to open this dialogue with industry now, early on. We want to hear what works, what doesn't work, what international experiences and lessons learned that you can share. We encourage the development of robust self-inspection programs that promote data sharing across the industry. In this day and age, everyone knows information is king. Big data, data sharing has its proven benefits. It doesn't matter what industry. So this one's no different as far as data goes. We don't want to miss an opportunity to create and share data that can be used by all of industry to promote safety. And this is our first step at promoting that idea. This brief is meant to frame our thoughts and present some of our ideas to you, maybe get some feedback, and then have a good discussion down the road at the August IPF. And that's the main takeaway that we're looking at today. We'd like industry to provide us some feedback on what programs work and what don't work in your experience. And we look forward to continuing this discussion down the road and hearing your thoughts. Thanks again to everyone that tuned in and is listening today. And I'd like to also wish everyone good health. Hope everyone's staying safe and healthy out there. Back to you, Brandon.
Okay, thanks very much to our presenters. We'll now be taking some questions from the audience. I thank you guys for presenting and giving those insights. I'm just going to go right back to Mark. Given that the U.S. has no operational utility scale offshore wind projects, and you mentioned that experienced developers will have some input into developing those standard, what are considered standard inspection procedures, how can developers provide that input to Bessie and Bohm?
Well, so we're planning on discussing this further at the IPF. And I'd say, down the road, we'll plan on having some, maybe some workshops, some industry meetings where we can get together and discuss some of these topics.
Wonderful. Great. Thanks so much. This question goes out to all three of you, and feel free to jump in, whoever feels most comfortable. What role, if any, does the U.S. Coast Guard have in these inspections that we've been discussing on this panel?
I'm going to take that. I'll take that. This is Sid. The Coast Guard's role is pretty much limited to the inspection of the vessels that are servicing the facilities. Once you step off the vessel onto the actual project itself, it's DOI's responsibility. And that's pretty much the demarcation there. It's pretty absolute. That also includes floating facilities.
So is that a corollary from that policy statement that was issued superseding OSHA? Does that have any interaction with this Coast Guard question?
It's a policy. I hate this. There's an agreement between the agencies, yes, and I don't know that maybe Mark or Christy have information as to whether we came out with a policy statement on it. But I believe it was a interpretation of the regs by DOI and U.S. Coast Guard.
Yeah, the policy statement that was referenced earlier was really just a preemption of OSHA. But like Sid said, the Coast Guard, that was in discussions with them, their interpretation of their regulations was that it doesn't apply to the facilities themselves, but to the vessels that service the facilities.
Great, thank you. Regulatory oversight in this respect is sort of sandwiched between what's pragmatic for industry, but also what is expected from the public. In the event of an absolutely worst case scenario, is the self-inspection regime that's outlined in 30 CFR 585, does that leave the government open to allegations or perceptions of a laissez-faire approach? Why or why not?
I'll try again. I mean, so people will have their opinions, and will be open to questions regardless of what happens. However, our approach is fundamentally sound, and it's tried and true. We're not only relying on self-inspections. We're performing our own audits of those inspections, and we have the as we covered in the slides, we have the regulatory authority to do our own inspections. So it's more than just a self-inspection requirement. It's self-inspection requirements with governmental oversight, auditing, and in fact, inspection.
So just to tie in the COVID-19 situation, of course, how do the inspections and assessment and reporting requirements that are in this exceptional circumstances? Okay. Okay, so it seems like we had a slight technical difficulty there, but I'm going to repeat the last question. How do the inspections, assessment, and reporting requirements that are outlined in 30 CFR 585, how will they account for a situation like COVID-19 where state governments may make different decisions, for example, about social distancing or something like that, and those decisions by state governments have impacts on workforces that are destined for for installations in federal waters? Does the regulatory structure account for those kind of situations, and how?
So I think that's part of the benefit of our regulations right now is that they are not incredibly prescriptive. They do allow for flexibility. They allow, you are giving us your plan, you're telling us how you're going to do it. But you have some flexibility within there, especially with the safety management systems. Again, you're going through and you're telling us what you're going to audit and how you're going to do it. But there's some flexibility in there. It's not like there's a hard deadline at this time, so we can work with you much easier. We can have the dialogue, and that's what our regulations allow right now, which actually works in really well with situations like this.
Great, thank you. Now, Sid, you had mentioned during your portion of the presentation what you referenced, or excuse me, what you described as a swim-through type of foundation inspection. And as Mark said, we want to try to minimize the number of people who are offshore to minimize the potential for incidents. Will there be a push to have these type of subsurface inspections performed by ROVs? Because this could not only reduce, how many divers we have in the water, but it could also, to the extent that these operating vehicles are following, programmed algorithms, this could increase the automation and repeatability of these surveys. Is this something that you're considering?
It is something that's it's currently done offshore, and I think it'll just be increasing, especially with a wind farm with a large number of facilities in close proximity to each other. I think it's the more efficient methodology for conducting what was referred to as a level 2 or swim through platform inspection. So yeah, we encourage it for the swim through type. The type 3, which requires the cleaning of the structure is a little more problematic, and to this point, it requires human intervention. So that would require divers. But if an ROV can successfully perform an action, we want to see it done. It's safer.
Sure. And I know that we had mentioned before that feedback was going to be received from the industry at the forthcoming IPF Together, which will be held in August in Providence, Rhode Island. But other than that, are there other avenues for collecting feedback from the industry? Is there an email address or a point person that industry actors should contact with their thoughts and suggestions in the interim before IPF Together in August?
So we have, if you're talking about developers contacting, we have a project manager assigned to each lease, and that would probably be the proper way to submit information through an email. If just someone not associated with a lease or developer, if just someone in general public had thoughts or questions, they could send it to our public affairs office, and they would direct it to the appropriate subject matter experts, which would be one of the three here on this screen, most likely. So,
okay, great, thank you. What age is Bessie responsible for inspecting cables, or are we just talking about the actual foundations?
Cables are specifically identified in our regulations as in the definition of facility, so they are part of facility, which is required to be inspected. So yes, they are in required inspection.
So again, given that we don't have any currently operational offshore wind facilities in federal waters, has any inspection document been submitted, or a beta test of a document, so that developers and other people responsible for conducting these inspections can begin to familiarize themselves with the actual document and the process?
The only document that I can think to point to, and Christy and Mark, you can jump in, is we did have commission a study under our renewable energy program study program. I don't have the title or reference number handy, but if anyone had any questions, they could certainly contact me and we pass it on. It's listed on our website under our research tab, and it's available to the public free of charge.
Great, thanks, Sid. I have a couple other questions here. Can these inspections, who actually does the inspections? Is it a contractor that's delegated by the developer, or is it a developer representative? Is it a classification society? Something else? Could you give us some insight on that?
So I can take that one. I mean, I think the best answer is it should be the entity that the developer thinks is best suited to do the job. If the developer or the operator believes that they can conduct the inspections themselves, they have the expertise, then that's perfectly acceptable. If they would rather bring in an OEM to do certain inspections, that's perfectly acceptable as well. It all depends on their approach to their self-inspection plan. If they want to employ certified third party to do their inspections, that's perfectly fine. It's just they can detail that in their self-inspection plan and submit that to us. And
so how does this panel see any new business opportunities for U.S. companies in this inspection process?
Well, I mean, I think there are.
Go ahead, Sid.
Sorry, Christy, I hate to talk over you. There's a lot of companies, existing companies in other locations that do offshore inspections that could potentially expand from other industries. And then certainly there's the opportunity for startups or expansions of onshore inspection companies to through a process of retraining or hiring of experienced individuals to move into new areas also. So yeah, there's always the potential for expansions as new industries come on board. Absolutely.
Christy, did you want to add to that?
No, similar. I was going to say, I don't think obviously we're not in the business of creating, those programs, but obviously opportunities present themselves anytime there is a new industry and regulations and new things to be submitted. There's always opportunities out there. And like Sid said, whether it is somebody coming in who has experience in a similar field, who just needs some retraining, whether it's somebody totally new, and there are companies out there that currently exist that can do it.
Wonderful. Thank you. Okay, Sid, I'm getting a live input in response to one of your last statements. You had said that level 3 inspections require divers. Apparently in the Gulf of Mexico, remotely operated vehicles can be used to clean and perform NDT inspections. Given this history of ROVs cleaning and performing these NDT tasks, NDT in the U.S. Gulf of Mexico, why would we not extend that work history to the renewables sector?
We would, in short, if an ROV can perform a function adequately, we would prefer, that's a preferred methodology, as we do it as safer to dropping divers down. If someone's familiar with the ROVs actually doing the cleaning and NDT testing without diver intervention, then they have better information than me, and I yield to their knowledge.
Well, Sid, you are the man of the hour. So I know that we have another panel on this coming up tomorrow, which we're looking forward to. But can you give us a little teaser and insight now as to the need or the lack of a need for a professional engineer on the self-inspection or CVA team?
Well, our regs do require the CVA have PE oversight, and for the self-inspection program and the actual individual self-inspections, we have no statutory requirement for it. We think it's best engineering practice and to have qualified individuals overseeing the work. And, to me, that sounds like a PE.
I agree there. We are looking for some more questions for our panel. We've got about another 15 minutes. So go ahead and please do type your questions into the chat box on the screen. We would like to take audience questions at this time. And we're looking forward to taking your questions. I would say that, just give me one moment here. So can you guys tell us about how we talked about how there's a number of different organizations that are qualified to conduct these inspections. How does a developer choose between whether to use a CVA or do it themselves? Are these business decisions, or is it just a matter of convenience? Can you provide us some insight on that issue?
I mean, those are decisions that are up to the developers. Some will have the qualifications in-house, which essentially is a business decision of whether you want to hire and retain, those kind of employees that can do it. More sense to go out and hire a contractor to do it for you. But those are really, internal decisions. And then you spell that out in your plan that comes to us, lay out the qualifications. We will make sure that there are qualified individuals to do it, and that the necessary inspections are being done.
So in the inspections context, what kind of lessons can be learned from offshore oil and gas or the European offshore wind industry? Are we incorporating some of the lessons from those prior experiences into our regulatory inspection framework?
I think we're attempting to. The biggest lessons that can be learned in terms of inspection is the documentation of where you start, right? Just post-installation, what is your reference point? What is your base point? And then doing the inspections, keeping up with them, keeping up with the data. Like you said, the data and the data sharing will be important But if you know where you started, you know your base case, and then you keep up with your inspections and you're doing those comparisons, it makes it a lot easier as you get down the road to make predictions for things like if you're going, you know, for life extension or repower, or just to see history and prediction of we've had this kind of storm come through. We know this is where we were right before the storm because we have all the information from our last inspection that was right before that, or 6 months before that, and we know where we were after. So I think that's one of the lessons that we've learned in oil and gas that we want to incorporate and we feel is important, and the data sharing, because there's a lot of knowledge that comes in from the inspections, from the inspection reports, and if there's a way to get that out to industry, it can benefit everybody.
I know that there's a lot of work that's going on right now, and I'm involved in some of it. I know that you guys are as well, to harmonize standards between things that apply to U.S. offshore oil and gas, U.S. onshore wind, and harmonizing them with the offshore wind, the standards that are applicable to offshore wind projects in Europe. How does that initiative, if at all, impact this portion of the regulatory structure that governs U.S. offshore wind projects?
Well, as we mentioned earlier, our existing regs are very non-specific. There's about 4 statements in them. So we rely on the developer to develop his plans and submit them to us. So we're working right now with some of the efforts on developing U.S. specific requirements, and we expect that the plan submitted by the operators would be in agreement with those, and we think that it's we're working hard to make sure that we're all on the same page moving forward, and we expect that to happen.
Well, I
We know
think
you're working hard, so thanks.
the more we can harmonize things, the better. Obviously, it's a global economy. It's there's manufacturers everywhere, so the more we can harmonize, the better. I think our push is, yes, we should harmonize as much as possible. We also have to recognize there may be some differences, and let's call those out and let's handle those differences. But where we can, let's keep it as similar as possible.
Agreed. This is sort of not a technical question, but sort of a nuanced question. Do these inspection plans need to be reviewed and approved by Boehm and Bessie, or do they just need to be made available for inspection?
The regs say you have to develop it and keep it on file, and we have the right to go and audit it. So there is no provision for review and approval. However, we'll be monitoring the performance of your safety systems and judging you based on performance. Is that
and there's a requirement
What's that, Mark?
And there is a requirement to submit an annual report. So, we'll have the auditors, the SMS auditors, the people that are reviewing these reports. They're going to have to, compare it to the plans and the SMS audits and kind of bring everything together to make sure all the bases are covered.
So this is a question that I had personally. We know that the Block Island Wind Farm is the only operational wind farm in the United States at this point, operational offshore wind farm in the United States, but we know that it is in state waters. Has Boehm or Bessie used that operational facility as any kind of beta testing ground to sort of work out any shortcomings that may exist in the regulatory inspection scheme, sort of, on site? No.
we're working with the Block Island Wind Farm on several projects. None that dealing directly with inspections, to my knowledge.
I don't know about on-site, but definitely it was used to help us go through our regs, identify what we need to clarify, what we need to make sure that we get ahead of for next time. So there were a lot of lessons learned and things that were implemented because of that.
I'd say
Go ahead, Mark.
the most of the lessons learned that we've experienced so far are with CVAL, Coastal Virginia Offshore Wind. And that's a small 2-turbine research project that's going off Virginia. And I'd say that since that is the first federal waters operation, that's giving us a very clear look of where the gaps are and certain areas that we need to focus on.
You anticipated my next question, Mark. So I do have another one that kind of ties into our next panel. How do we, obviously we're not there yet, but how do we envision this regulatory structure applying to a floating offshore wind platform or facility?
Well, the same. Are you specifically asking about the inspection portion? I mean, it has the same process, and that's the process is a performance-based process, and it's developer-driven, and therefore it's open to be applied to, different support structure configurations. It's equally applied to monopiles, to jackets, and to floaters. So if you go through the process correctly, and you have the experienced personnel involved, then when you get to the end of it, you have the right answers. And so that's the basis for the process.
So the fact that a floating platform is floating doesn't implicate any kind of Coast Guard jurisdiction?
Based on BOI and Coast Guard's interpretation of the regulations at the current time, no, it doesn't.
Okay. Are there any specific post-repair inspection requirements? Let's say a facility loses a blade or something after the intense environmental front that we had described. Is there some kind of post-repair inspection that's required by the regulations?
Not specifically called out, but we do have our maintenance and repair report requirements in Section 17, and we would expect a post change or a post repair report that would include any required testing and pictorial evidence and et cetera. That's part of that maintenance and repair reporting requirements.
So at what point in the offshore wind developing process does the inspection program, let me start over. At what point in the development process do the regulations require the inspection program to be defined? Is it at the COP, the FDR stage, final investment decision?
You have to have your inspection program developed prior to entering service. Is that correct, Mark?
Yeah, I mean, I the regulations are specific on it, but it's tied to your SMS, your safety management system. So you have to demonstrate your SMS is fully functional 30 days prior to construction. So I would think that your inspection plan and your inspection program should be in place and demonstratable about 30 days prior to construction. It goes hand in hand with the SMS.
Great. Okay, I think we have time for one more question. In the event there is a disagreement on a remedy that is required pursuant to an inspection, how is that resolved? In this case, what enforcement action can be taken by BOEM or Bessie?
Well, I mean, I think first we start out with the dialogue, right? I mean, we want to have that conversation. We want to hear from the CBA or the leasing, whoever has done the inspection, is making the recommendation on what to do, and see if we can work it out. The enforcement action comes really if there is an incident, right? Then we can take an enforcement on it. But I think we would try to work it out. But in the end, if it's in our regs and it's something there, then we can enforce it. It's that's our job to do so. Sid, do you have?
I mean, I think it. the ultimate enforcement action is you've violated your lease and your cessation of commercial activities. It's not something that I think would be used frivolously, but I think that the majority of disagreements will be resolved amicably after a certain amount of back and forth. And at the end, as Christy said, we are the regulator, and your requirements are spelled out in the Code of Federal Regulations and in the lease, and you must adhere to both of them. So, yeah. The attorneys can argue what that means.
Okay, well, we're going to leave it there. That does it for our second panel. Please join me in thanking Christy, Sid, and Mark for shedding some light on these really interesting regulatory requirements. Up next is our third workshop for today called Planning for Offshore Wind Energy Development on the West Coast. We'll start at 11:30 a.m. Eastern. Stick around.
Thank you, guys.
Welcome back, everyone. And for those of you who are logging in for the first time today, thanks for joining us. Just a quick reminder that IPF Virtual is being recorded. A link to the recording and presentation slides will be sent to the email address that you used to register. If you have any questions for the panelists, please go ahead and type them into the chat box during the course of the presentations. And finally, the network would like to thank all of our IPF sponsors, specifically our 2020 host, the state of Rhode Island, and our IPF Virtual partner, the law firm of Womble Bond Dickinson. And now, I'd like to introduce our next workshop entitled Planning for Offshore Wind Development on the West Coast. This panel will be discussing the efforts that are being made to advance floating offshore wind projects in the Pacific. Please welcome our moderator, Chris Potter, who is a Marine Renewable Energy Program Manager at the California Ocean Protection Council. And please welcome our panelists, Nessie Sumai, Renewable Energy Section Chief for the Pacific Outer Continental Shelf at BOEM, Jason Bush, Executive Director of the Pacific Ocean Energy Trust, Arnie Jacobson, Director of the Schatz Energy Research Center at Humboldt State University, Philip Biter, Energy Markets and Policy Analyst with the National Renewable Energy Laboratory, the Business Network's own Western Director, Nancy Kirshner Rodriguez, and Ala Weinstein, CEO of Castle Wind, which is a joint venture between ENBW and Trident Winds. Chris, take it away.
Thank you, Brandon. Before I turn things over to our first panelist, Nessie Sumai, I wanted to provide some context on offshore wind development in California and the actions that the state of California and specifically my agency are taking to foster it. California has an aggressive statutory renewable energy target of 50% renewables by 2025, 60% by 2030, and 100% clean carbon-free electricity by 2045. To help achieve these long-term energy and environmental goals, the state is exploring emerging technologies such as floating offshore wind that might be able to provide renewable zero-carbon energy. In addition, state law commits California to reducing greenhouse gas emissions by 2030 to 40%, and by 2050 to 80% below the 1990 statewide GHG emission levels. State law also requires that the California Electricity Portfolio Planning process, the IRP process, to focus on resource mixes that can reduce GHG emissions. The offshore wind potential for Central California is very good, and for Northern California, it's even better. On the Central Coast, wind speeds are just above 7 meters per second, and on the North Coast, they're almost 10 meters per second. It's also worth mentioning that some of the offshore wind resources are located near major load centers, and as coastal power plants retire in response to California's once-through cooling policy, these locations may become opportunities to integrate offshore wind with existing transmission systems. The capacity factor for California's offshore wind resource has been calculated to be more than 50%, which is higher than California's energy resource capacity factor, solar energy resource capacity factor of about 30%. The challenges for wind development, offshore wind development in California is significant, but not insurmountable, because floating turbines will have to be used, and wind farms will most likely be located at least 20 miles from shore. Development costs will be much higher compared to those for developing other renewable resources. Environmental impacts are something that the state is especially concerned about. For example, effects on whale migration and bird strikes. Also, while California has experience in permitting oil and gas projects on the outer continental shelf, we don't have experience in permitting offshore wind projects. In February of this year, my agency, the Ocean Protection Council, approved a new strategic plan. The plan has many objectives and targets that relate to the climate, equity, biodiversity, and the blue economy. Specifically, we have an objective that addresses offshore wind development, and it states that the OPC will work with other state agencies towards the development of a commercial scale offshore wind project that minimizes impacts on marine biodiversity or habitat, currents and upwelling, fishing, cultural resources, navigation, visual, and military operations by 2026. The goal will be achieved through two primary actions. One, work with partners to develop a statewide policy that will establish criteria by 2024 to ensure responsible evaluation and potential implementation of offshore wind projects consistent with state law. And two, continue what we're doing already, and that's funding research and primary data collection to assess environmental and socioeconomic impacts of potential offshore wind projects. Starting in 2018, the state of California began funding critical research that will provide useful and important information during the planning and environmental analysis phase of offshore wind energy in California. For example, we're currently funding, in conjunction with the Bureau of Ocean Energy Management and the Governor's Office of Planning and Research, a North Coast offshore wind feasibility study. Dr. Arnie Jacobson from Schaff Energy Research Center at Humboldt State University will be discussing some of the results from this study during this panel this morning. Now with that, I'd like to turn things over to our first panelist, Nessie Sumai. She is the Energy Section Chief with the Bureau of Ocean Energy Management in their Pacific region.
Great. Thanks, Chris. Hello,
You're
everyone.
Please go.
Going to provide a brief overview of BOEM's leasing process and also talk about some of the activities that we are involved with regards to offshore wind in the Pacific. So the states in the Pacific region under the Pacific office includes California, Oregon, Washington, and Hawaii. We do have renewable energy task forces in all of the states except for Washington. And as Chris said, because our waters get deep just a short distance from shore, we're expecting that floating platforms will be the technology that we'll see here in the Pacific region. There are no BOEM leases in the Pacific right now, but we are in the early planning stages in California, Hawaii, and Oregon. Next slide, please, Chris. So in Hawaii, BOEM in 2016 identified two call areas, offshore Oahu to the north and to the south. The call for information was published in 2016, and we did get several nominations of interest. Currently, we're in discussions with the state to try to determine the next steps for going forward with offshore wind in Hawaii. In Oregon, we are processing an unsolicited lease request for a wave energy test site. For marine hydrokinetic facilities, we share jurisdiction with FERC. FERC issues the license for construction and operation, and BOEM issues the lease for the project. We resumed the conversation on offshore wind in Oregon, and we held a task force in September of 2019. The result of that task force was for BOEM and the state through the Department of Land Conservation and Development to put together a data gathering and stakeholder outreach plan for task force review. We had planned on doing a task force webinar in April, but that has since been postponed, and we're working with the state to see when we can schedule that. So stay tuned on Oregon activities. The remaining three maps here on this slide include those of California. On the bottom there shows the three call areas that we identified in a call for information and nomination that was published in 2018. There is a site on the North Coast called Humboldt, and in the Central Coast, Morro Bay and Diablo Canyon. The larger map here shows a map that was discussed in the most recent task force in California in March of this year. We show here additional areas that has been identified by a working group that was composed of staff from congressional offices, as well as the Department of Defense, BOEM, the California Energy Commission, NOAA, National Marine Sanctuaries. And those discussions led to additional areas in and around the Morro Bay to the north and to the south. The difference being that the original call area were about 20 miles from shore. These additional areas approaches the shore at like 17 and 15 miles. from the coastline. We had also planned a coastal community outreach plan that has been delayed. And so we are working with the state to identify our plan going forward with regard to outreach on these additional areas. Next slide, Chris. So in addition to our leasing activities, BOEM also is involved in a very robust study program. I've put here selected work that we are funding or managing in the Pacific region. The first one is in collaboration with the Department of Energy through the Pacific Northwest National Laboratory. BOEM is deploying 2 LiDAR buoys offshore California, one on the north coast and one on the central coast within the call areas. I believe that there's a panel after this one that will talk a little bit more about those activities. And with fingers crossed, we are hoping that we can still deploy these buoys before the end of the year, probably late summer, hopefully. And as Chris said, in the North Coast, there's good wind potential, but transmission is a challenge. And so BOEM is funding a study done by Shas Energy Research, along with other studies that the state is doing, as Chris mentioned, to try to understand the transmission issues on the North Coast. And Arnie, later on today in this panel, will talk a little bit about that work as well. In California, the California Public Utilities Commission is charged with integrated resource planning. So with NREL, BOEM is working with the California Public Utilities Commission to provide inputs and assumptions about offshore wind so that it can be considered as they move forward in developing a portfolio reference plan for their utilities for power procurement. Philip will speak about that work that we are doing with the PUC. Another project is with NOAA, USGS, the Monterey Bay Aquarium Research Institute, and the University of California Sea Grant. We are doing a deep water mapping and benthic characterization offshore California and Oregon. And the project is called Express. So that's a nice way we're collaborating with several entities to optimize limited resource research funds. Also in Oregon, we have a small project with the Pacific Northwest National Laboratory to try to explore the grid value potential of offshore wind energy in Oregon. So PNNL is doing a white paper to help inform on the value proposition of offshore wind to the power system beyond energy. You can look at our website for additional scientific research that we have. I have the link here. And finally, just to let everybody know that we are sharing all of our scientific research that we've done in the Pacific Coast through a series of webinars. We've done 3 of them. One on like a general overview and use of spatial data. We also did one on birds. We did one on fishes and fisheries. And the next one is going to be on marine mammals, and that is scheduled for May 13th. These no-cost webinars are available to everyone, and you can go to our website for the links. And I believe that's all I've got. So thanks for the opportunity to present, and I turn it back to you, Chris.
Thank you, Nessie. Our next presenter is Jason Bush. Jason is the Executive Director of the Pacific Ocean Energy Trust.
Good morning, and thank you very much for the invitation to present today. Easiest travel ever, presenting across the country this morning, still in my slippers. I think this is the first. So I've been tasked with providing a quick overview of the policy landscape for Hawaii, California, and Oregon. I'll start by saying that the West Coast and Hawaii lack any offshore wind specific policy provisions. Nevertheless, the markets for offshore wind in these states are being driven by the existing goals, mandates, and policies related to state measures to address carbon and climate change. Two additional factors include growing load and decommissioning of existing thermal resources especially in California. Starting in Hawaii, really one of the first states to set a 100% renewables goal, in this case by 2045. But clearly that's going to be a solar and storage dominated market for the foreseeable future. And while offshore wind resources are good, a combination of three issues, I believe, will dampen the market for the foreseeable future. First, the islands are not grid interconnected, and Oahu may be the only island with enough load to absorb an offshore wind project of any commercially viable size. Secondly, the Department of Defense has not indicated its interest in accommodating offshore wind at this point, especially off Oahu. Think Pearl Harbor and Marine Corps Base Hawaii at Kaneohe Bay. And three, there is a generalized local antipathy for energy projects, or really any large projects for that matter. So the existing wind projects that are in process today are, I think, in limbo at this point, and will likely remain that way unless something changes. Moving next to California, I think it's important to note that California is a market in transition. Clearly, the market is promising for offshore wind. They've got the requisite 100% clean energy mandate. They've got growing load and literally gigawatts of nuclear and natural gas facilities coming offline. But other major factors may need to work themselves out before California is able to fully embrace offshore wind, including grid regionalization, out-of-state wind, how the CCA story plays out there, community choice aggregators, and how that affects procurement in general, as well as centralized procurement in the state. And of course, the ongoing PGE bankruptcy and fire risk issues. So how these play out, I think, are all very relevant factors that will affect when, but not whether, offshore wind launches in California, which I very much think it will. As of 2019, California has a new trade group that is exclusively focused on the California floating offshore wind sector. It's called Offshore Wind California, with our new executive director, Adam Stern, and energy lobbyist, Kelly Boyd, who are both working hard to coordinate with the Business Network and with the WIA California to present a unified front and focus on their respective strengths. OWC's focus at this point could be reduced to three topics. First, establish a marketed goal in California of 10 gigawatts by 2040. Much of the effort today is laying the groundwork that we hope will lead to the state embracing a 10 gigawatt goal sooner than later, we hope. That's going to require some serious research and planning to get there, as well as a lot of support from our natural partners from the environmental NGO and labor communities. I also think a possible implication or even upside from COVID will be a much higher sense of urgency to invest in opportunities that have high potential for getting people back to work. Large infrastructure projects like transmission and port infrastructure may be primed for stimulus money, and such investments could help kickstart the offshore wind sector in California and beyond. I think we're also keen to see the BOEM leasing process proceed expeditiously, and we're committed to working with our partners and stakeholders to identify viable and adequate space on the ocean. We see the new additional areas identified around the Morro Bay area as a good sign that folks are leaning on this issue, but it's clear that we're going to need continued and concerted state and federal leadership to help resolve lingering questions about compatibility, especially with regard to the Department of Defense. And finally, I think we're all working on carving out the value proposition of floating offshore wind, not just for California, but everywhere, though I think each location will be unique. I know there have been and will continue to be efforts to identify and quantify the various values of offshore wind, and we need to be expansive about that approach, clearly including the ancillary grid benefits, as well as local benefits, such as flattening the duck curve in California or improving grid quality on the coast of Oregon, as well as grid reliability and resilience, and of course, the significant economic benefits for this very promising sector. Moving on to Oregon, we have an existing RPS of 50% by 2040, but more importantly, Governor Brown just signed Executive Order 20-04. This executive response came on the heels of 2 years of failed legislative efforts to pass a cap and trade program after Republicans left the state 2 years in a row to deny the legislature reform, and thus killing the highly negotiated carbon cap and trade legislation, along with all other legislation for that matter. The new executive order is a fairly comprehensive regulatory approach to the three main carbon sectors. Of course, this happened about a week before the dreaded COVID, So we're in limbo for now, and it will probably be several months before the real work of rulemaking gets started. We were supposed to have our next BOEM task force meeting on April 2nd, as Nessie indicated, but that was canceled for obvious reasons. But it effectively signals the beginning of the planning process to identify wind energy areas in Oregon. And I'm also pleased to say that there appears to be significant local coastal support for offshore wind, with citizens coming together to help drive development, especially in the southern region. And POET has recently brought on some new staff, and we're focused on creating a supportive policy environment for offshore wind in the state over the next 2 to 3 years. Finally, I want to briefly highlight the fact that there is a new group coming together whose goal it is to help establish the research agenda to address the key environmental risks that require additional in situ work. This new group, called POWER, the Pacific Ocean Wind Energy Research Group, consists of environmental NGOs and industry, and will soon begin the work of identifying a prioritized research agenda. So stay tuned for more on that effort in the coming months. That's it from my comments. Thank you for this opportunity. I'll turn it back to you, Chris.
Thank you, Jason. Our next panelist is Dr. Arnie Jacobson, Professor of Environmental Resource Engineering at Humboldt State University.
Thank you, Chris. And next slide. You can actually go one more. So I'll be focusing on offshore wind potential or feasibility on the North Coast, and we're currently working on a suite of projects that cover a number of different aspects of this, funded by the Bureau of Ocean Energy Management, the California Ocean Protection Council, and the California Governor's Office of Planning and Research, with each of those funders covering a different set of topics. I won't list all of them, or I won't talk through all of them. They're listed here on the screen. But what I do want to focus on today is the grid interconnection and transmission related topic. Next slide. In addition to our funders, which are shown here, I want to acknowledge our major partners in this effort, which include Pacific Gas and Electric, Mott MacDonald, H.D. Harvey and Associates, and the Navy Region Southwest. PG&E in particular has been a key partner on the transmission analysis, and we've also had support in that analysis for the subsea cable aspects from Mott MacDonald. And Mott MacDonald's also worked with us on some port infrastructure assessment, and H.D. Harvey and Associates has worked with us on a number of aspects of the project related to environmental dimensions, environmental impact assessment. Next slide. In terms of key take-home messages associated with this work, I think, as others have said, both Chris and Nessie, the offshore wind resource on the north coast of California is very large. It could represent a significant contribution, if developed, to California's 2045 goals of 100% clean electricity. If you look at a full build out of the Humboldt call area that BOEM has identified, that could be could fit up to 1.8 gigawatts of installed capacity, and there are other areas, if identified in the future, that could expand that even further. So there's a fairly significant capacity for development here. However, in order to realize that, in addition to overcoming a number of other issues, transmission is a particularly large constraint that would need to be overcome. Currently, the Humboldt region is connected to the main grid by, if you want to use a circulatory system analogy, we're connected by a few capillaries when what we need is the aorta or maybe multiple aortas. The image here on the screen shows one of the 115 kilovolt transmission lines, which is one of the main lines connecting Humboldt to the rest of the California grid, sitting underneath a 500 kilovolt line, and we would need probably multiple 500 kilovolt transmission lines in order to fully support a large build out of that transmission capacity. Of course, there would be other issues that have to be overcome as well, including there's some port infrastructure issues, environmental impacts, stakeholder issues. There are seismic hazards that have to be thought through. So a number of other issues, but really transmission is I think the make or break issue. If we would need to identify a solution for that in order to move forward. As I said, we're engaged in analysis to address that, and we expect to be releasing results from that over the coming months. I think with that, I will pass things back over to Chris. Maybe you can go to the next slide just for the closeout, and happy to talk more about this in the discussion portion of the session.
Thank you, Arnie. Our next panelist is Philip Bider with NREL.
Great. Well, thanks, Chris. So I'll be providing remarks about two NREL reports focused on site feasibility and technology cost assessment of floating wind technology along the Pacific coast. The report we conducted for Oregon was published last October and is available publicly. And then the second report, which is very similar in its approach, focused on California, is ongoing work, and we expect the results of that, so report and associated data, to be available by the fall of this year. Both of these work efforts were funded and sponsored by the Bureau of Ocean Energy Management, as Nessie mentioned before, and are intended to provide the data and background to inform the planning of the future energy system in both states. Next slide, please. So for the analysis we conducted for Oregon, we identified 5 study sites that are shown here in this map on the left. Those sites were selected based on technical site selection criteria, together with POET and parametrics. The parameters we considered were wind speed, which had to be greater than 7 meters per second, water depth of less than 1,000 meters, ability to connect to the bulk transmission system, and a viable distance to construction and imports along the Oregon coast, and a distance of at least 12 nautical miles from the coastline. The size of these areas were also carved out so they could accommodate 1,000 megawatts of offshore wind. It's important to note here that the sites were identified for cost analysis purposes only. They do not represent the outcomes of a marine spatial planning effort, as would be conducted by BOEM. The cost of energy on a levelized basis that we found or that we estimated for Oregon is shown in this graph below. For 2019, for commercial scale 600 megawatt plant floating offshore wind using a semi-submersible substructure, we estimated a range of about $110 to $160 per megawatt hour. The difference in the LCOE between those sites is closely tied or driven by the capacity factor. So site 1 in the very north of the state, we assess to have the highest LCOE, and site 5, which is in wind speeds of close to 10 or even above 10 meters per second, is the site that came in with the least cost of all the sites considered. We also took a look into the future and projected costs out to into the early 2030s. And so we projected that by 2032, This cost range between the sites would reduce to about $50 to $75 per megawatt hour. The drivers we identified for this reduction, well, there's really three of them. One is the increase in turbine rating that we're expecting during this time, and improvements with the substructure. Secondly, there'll be improvements that we've assumed in the fixed bottom supply chain, which in part translate over to the floating industry. And then thirdly, a set of technology innovations that we've estimated will allow for those cost levels, such as improved blade design, next generation generator technology, quayside assembly, et cetera, et cetera. Next slide, please. So now turning my focus to the ongoing study that's focused on California. So very similar in its approach, this study is intended to provide updated floating cost and performance assumptions for consideration of the technology in the Integrated Resource Plan by the California Public Utility Commission, which is used for the long-term identification of new resources such as offshore wind. We're analyzing the entire outer continental shelf in California, including the call areas, for a time period between 2019 and 2032, and we're extrapolating the cost trend that we find within this time range out to 2050, as that is required input for the RFP. We're looking at 3 primary turbine ratings to be deployed during this time period, a 10, a 12, and a 15 megawatt turbine. And we're looking at plant sizes between 600 megawatts to 1.2 gigawatts. This cost modeling effort is building on an earlier study that was published in 2016, where we also looked at 5 study sites. Now, 4 years later, we found that a lot of the assumptions that went into this earlier study have quickly become outdated, reflective of how quickly both the fixed bottom and the floating industry have moved over the past few years. For this assessment, we're using NREL's latest modeling and capabilities and data, and including a new assessment of the resource of California, which we're extending to encompass a 20-year mesoscale resource assessment. And we're building on the latest data available to us as validated by industry partners. Lastly, I wanted to call out again the sponsor for this work, BOEM, and our informal collaboration partners such as the CPUC, the Schatz Energy Center, and the California Ocean Protection Council. The next slide has my contact details on it. I look forward to the discussion, and with that said, I'll pass it back to Chris.
Thank you, Philip. And our next presenter is Nancy Kirshner-Rodriguez with the Business Network for Offshore Wind. Nancy, you may be on mute.
Thank you very much, Chris and colleagues. It's good to be with all of you from across numerous oceans. And I think this panel really demonstrates the breadth of partnerships that do and must exist for offshore wind to succeed, particularly off the west coast of the US. And the Business Network is committed to providing the entire supply chain a strong voice in this development. We are bringing our experience and expertise from the East Coast and our global partnerships and relationships to the West. As you've heard, this is a decade of enormous potential for all of our states. And we, at the same time, recognize that there are many obstacles that must be overcome to lay the groundwork for the success of this industry. The slide that you see here is the big circle that really shows how much potential there is for a West Coast supply chain as the industry develops and things become more clear of exactly where the siting is going to happen, when it's going to happen, but we want to get started early. So we are focused on partnering with West Coast states to begin soon the process of developing a registry similar to what we have done on the East Coast and really building those out. This will allow companies to indicate their interest and ability to supply components and services for U.S. offshore wind projects. And it will also serve as a valuable resource for companies looking to buy from and partner with other offshore wind firms. As most of you know, because you are part of this industry, the supply chain covers everything from development, construction, operation and maintenance, and all other related services. And you can see here the depth and breadth of those. We, and truly, one of the things that we are trying to do now is take a look at what types of companies exist that could be focused on mooring, focused on anchors, focused on really things that are going to be new and particular as well to the floating market, which is what we will be focused on. We recognize as well that there is going to be the need for investment and partnership from the different states. And as you've already heard, I think our states are starting to really look at that. And also local businesses are really starting to examine that. So I will be happy to answer questions afterwards, and we'll look forward to talking with all of you about next steps and where we're really going to see both the supply chain and the workforce that will be needed to build utility scale offshore wind in the Western states.
Thank you, Nancy. Our next and final panelist is Alla Weinstein. She is the founder and CEO of Castle Wind.
Hi, everyone. It's a pleasure to be here in this virtual mode, and I'm glad we're doing this. I'm going to talk about the West Coast and the offshore wind. And since you heard from the previous speakers about what is and isn't possible, we're going to talk about what is the value of offshore wind to the West Coast. Chris, next slide, please. So looking at the West Coast, I think you need to actually project the whole Western region. You may or may not know that the Western region is managed by the Western Electricity Coordinating Council, and that integrates a number of Western states into not necessarily interconnected region yet, but at the same time, there is a lot of interactivity that goes between all the Western states. So there was a study looked at the flexibility of the Western market done at the end of last year that basically determined that in order for the Western region to be more integrated and reach 69% renewable energy penetration by 2035, it needs to add almost 9 gigawatts of renewable energy per year. That's a significant amount of energy that has to be put in. And what that study also identified, that new technology, including offshore wind, can add to the supply of the diversity and flexibility solution to the region. So if we talk about only states like Washington, Oregon, California, that's only potentially a beginning. The rest could be expansion because all the states will need flexibility And offshore wind can be that resource that offers diversity, resiliency, adequacy, and flexibility. So that's the whole West Coast. I'm not going to talk about where, again, in Washington, you already heard about it from Nessie and Jason and other speakers, but I'll focus on California and how the opportunities in California can be translated into real projects. At the end of 2018, Castle Wind commissioned a study that was conducted by E3 that does a lot of modeling on what is the value of offshore wind to California itself. And we found out, which was also confirmed by another study funded by the Ocean Protection Council, that approximately 10 gigawatts of installed capacity of offshore wind in California can provide the least cost benefits of almost $2 billion towards achieving SB 100 or 100% renewables and climate goals to the state of California on an NPV basis. That is a significant amount of energy, and it's a significant amount of savings. And so offshore wind as a resource cannot be overlooked. The picture on the right-hand side that you can see has a blue line. That blue line is the offshore wind. And if you look at the value of offshore wind compared to all the other resources, you will see that it has the highest value out of all of them. The black line is the value of the resource that's available to the consumers and to the state of California. So it is a resource that cannot be overlooked. It is a resource that needs to be put into the planning. And it is a resource that does offer diversity, reliability, adequacy, and flexibility. Next slide, please. So while there are a lot of opportunities, there is still a significant amount of challenges. We do know that the market demand is there. That's what demonstrated by the studies that were conducted in the last couple of years. California needs offshore wind to meet its energy and climate goals, but it does not yet have a goal. We know that on the East Coast, it's the governors and the states that created goals that moved and propelled the market forward. We need the same thing in California as well. We also have a significant challenge in the sea space. While the wind resource is adequate in Central California, as Chris and Arnie described, it is very good in Northern California, but your load is in Central and Southern California. So just relying on the Northern California resource may not be adequate because the state has a very, 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 very long coastline. And so your Central and Southern California markets are quite a ways away from the Northern California. Fortunately, the Central California has very good resources as well, but it has significant conflicting uses of space with the Department of Defense and National Marine Sanctuaries. And there are 3 of them. So we can't just assume that even though the ocean is big, that it's available for use. It's not, and it has to be carefully planned. And on top of all that, we have very deep waters. These are probably the deepest waters around the world so far. It's 800 to 1,300 meter water depth is the areas where we're going to be looking to install floating offshore wind. We do have transmission capacity. However, timing is of the essence. While it's still available in Central California, it will be taken out very quickly by land-based projects. So as you heard from Arnie, to put transmission in Northern California will take significant amount of time and effort. We do have it in Central California, but we should not lose the opportunity, because if transmission is gone, then we'll be back to needing to build more transmission lines. And that's something that should be avoided. And that's timing is of the essence. On the procurement side, offshore wind has to compete with all the other renewable energy in California. California is different from all the other states. State does not buy energy. It is bought by end users or utilities or community choice aggregators. And that would mean that every developer has to negotiate multiple PPAs with multiple parties, which is, again, a challenge, but it's also an opportunity because it's direct negotiations. Next slide, please, Chris. So if we look at how can we get from here to there, well, there are a couple of things at the offshore wind strategy that should be implemented. One of them, the goal should be set by the state. And based on the studies conducted both by Castle Wind and Ocean Protection Council, it should be 10 gigawatts by 2040. We can do it, and California needs it to meet its climate and energy goals. Also, as you heard from Nancy, industry needs scale and a pipeline. The supply chain will come, investments will come. We need a commitment, and that commitment will drive and propel the installation of the projects. Now, we're going to focus on Central California because Northern California, while it doesn't have issues with Department of Defense, it has transmission issues, and that's a different story. But we do need to free up space in order for the projects to be realized. In Central California, Department of Interior and BOEM, the state and Department of Defense must agree on a phased approach development in what we defined as a planning area. The map on the right-hand side shows an area outlined in black. You did not see that map on Nessie's slides because that is the area that we as Castle Wind and some other industry partners have identified as the maximum potential available for offshore wind development. Why is that only the area available? Well, because we're limited. We're limited on the east by the Monterey Bay Marine Sanctuary, which is not in BOEM jurisdiction, where the same thing is on the north. We're limited on the west by a very deep canyon with a very steep slope. And so we believe the 1,300 meter water depth is probably the maximum we can go to before the slope becomes unbearable. And on the south, we're limited by Department of Defense activities and primarily Point Mugu Sea Range. Those are limitations. And when you take all these limitations, you basically see you have a maximum of 730 square miles available for any offshore wind development. And so we do need all these agencies, state, DOD, and DOI/BOEM, to come to an agreement to allow phased development of offshore wind in the planning area, which does include the Morro Bay coal area, and the conditional development, whatever they are going to be, outside the planning area. But we do call on those three agencies to come to an agreement. We can't just sit and wait. We really do need to move things forward. And so we would like to see BOEM to be able to conduct an auction as soon as possible in the Morro Bay coal area. That has been defined, comments have been received, and we need to move forward. And if we can get to those agreements, then we can see improvement, or they can see the benefits that offshore wind can bring to California as well. We have a great public support in the Central Coast, and we should be able to use them, including fishermen, that actually support offshore wind development. And we do need transmission and procurement, and that CPUC has to include offshore wind in the integrated resource plan. That is the plan that drives transmission planning, and it drives demand that utilities can procure. And so all these things, if they can come together, we can see significant development in Central California. Other markets like Oregon and Washington and Hawaii will come with time because today California does have the largest market. Next slide, please. And as Greta Thunberg said, instead of looking for hope, let's take an action. So let's do it. Thank you.
Thank you, Ala, and thank you, everybody, for this panel. And Brandon, I think you're going to key up questions. I have some questions already.
Yes, I just wanted to. We're gonna transition to the Q&A portion of our California panel. Thanks very much to Chris as our moderator and to all our esteemed panelists. Just a quick note for the audience before we do that: if you are experiencing any buffering issues or freezes on the video with your video feed, please go ahead and refresh your page. Chris, you said that you had some initial questions for the panel.
Yeah, these were questions that were sent to, I guess, were a result of a survey to attendees. So I'll put this out there to everybody, actually. What are the major differences and challenges in the West compared to the East Coast of the U.S.? And we're talking, environmental challenges, ecosystem components, energy demand, all the way to societal and political culture. It's a pretty broad question, but I feel if there's any one panel at this conference that could answer the question, it would be this. Nessie?
I'll start. Clearly, we're going to run into similar issues in stakeholder outreach. There will be a regional flavor, but we'll have the same stakeholder concerns from current users, from vessel traffic, from the fishing community, from coastal recreations. Those will be there with us. We don't have pile driving in the West Coast, but we also have now subsea cables. So it introduces a new set of conversation with regards to potential impacts to small mammals and the habitat for the anchoring. And as Ala said, I think the market in California is also very different than in the East Coast. We are blessed here in California to have multiple renewable energy resources that's available to us. The offshore wind has to be able to compete. Oregon has the cheapest power with hydropower, but because it has a very effective transmission system, it also is able to use that hydropower. So I think the states here have very aggressive renewable energy goals. They want 100%, California and Hawaii both. Oregon knows how to do, has done transmission in the past. And so I think we're learning from the East Coast. And I think, the Pacific states will catch up and we'll get to an offshore wind industry at some level. So I'll stop there.
If I may
Thank you,
add
Nessie.
to if I may add to what Nancy said, I think
Please do.
other things that we don't have right now that it does exist on the East Coast, and I kind of mentioned that it's the goal set by each of the states to what amount of offshore wind we should be bringing in. That's going to be significant because again, it's a market signal, and it helps supply chain to understand what to plan on. The other piece that's different, while on the East Coast, it was the environmental community that actually drove and pulled offshore wind. That is not the case on the East Coast, on the West Coast. And the reason is because there is already, it's a different population density, it's a different resource diversity, and it's different from all the aspects. So we do need to work with the environmental community to explain and to show the benefits of offshore wind, which was not necessarily the case on the East Coast.
I have a question, and I will put this out to the panel and allow anyone who feels qualified to answer it to go ahead and do that. We've been hearing about California offshore wind leasing for years now. How strongly has the Department of Defense weighed in regarding offshore wind development in California? What is their position regarding offshore wind, and how can the industry address any concerns that DoD may have?
Nessie, why don't you start, then I'll finish.
I figured I would have to start. Very much so. The Department of Defense has been engaged in the planning. They have a unique set of operations in the Central Coast. So whereas there's no issues on the North Coast, there are significant issues in the Central Coast. And so they have been there from day one. And I think, maybe the map that was shown there are baby steps, but we're inching, and they are inching closer to shore. But I think that DoD is trying to work with the state and BOEM, and I think it's good to have industry. Industry has also been involved in the conversation, and I think them continuing to be involved will also help the discussion as well. So.
In 2019, Representative Carvajal from the Central District, particularly San Luis Obispo, formed the working group, or he called to resolve the issues with Department of Defense. And in a way, the map and the additional areas that Nessie showed are the result of these discussions that were led by Representative Carvajal. As you know, because of the significant activities that are happening on the Central Coast, particularly in Point Mugu Sea Range, that is the area that has been of the greatest concern to Department of Defense. And if we together, between the industry and the government, both state and federal, can come to some resolution of this conditionality that Department of Defense is imposing, then that's what will free up and move things forward. And that's exactly what needs to happen right now, and that is what's happening, which is led by Representative Carbajal, and we're hoping that these discussions will continue. It is, we all got impacted by the coronavirus with things that could not happen, like public meetings that were supposed to happen and show what the visual impacts are going to be with installations closer to shore. And I'm hoping that BOEM and the state will be able to move those things online and do things in virtual mode so that we don't delay things any further. But it is happening, it is going, and discussions continue.
Brandon, may I say one other thing?
Sure.
I think it's important to also, for us, as we push this forward and push these conversations, to really emphasize the potential for the West Coast to build a global supply chain and market. And I think the more we can do to demonstrate that economic benefit and potential, even beyond our Western states, is going to be very important as well for pushing the dialogue forward and making the case for why the agreement needs to happen now.
Great. Thank you, Nancy. We have about 4 minutes left. And I have one really interesting question here. Taking into account the unique wildfire vulnerability in California and discussing the transmission upgrades that were mentioned by multiple presenters as being necessary to integrate this amount of offshore wind capacity, is an offshore transmission system being considered?
I can say something about that. Exploring an undersea cable is part of the scope of our analysis on the North Coast, and I think there is there are interesting possibilities there. An undersea cable that moves from the North Coast to the load centers in the Bay Area would only make sense once you get to significant scale. It wouldn't make sense initially if you're looking at a few hundred megawatts of capacity, but once you maybe move into the gigawatt scale, I think it is an interesting possibility. There are a number of challenges associated with an undersea cable, both from a technical and environmental perspective. There are significant challenges, and also in terms of a point of interconnection, figuring out where you would bring it on shore or interconnect. The load centers that would make most sense are in the Bay Area, but figuring out if you go through the Golden Gate or connect on shore somewhere north of the Golden Gate, there are no easy options there. So I think undersea cable could make a lot of sense, but also faces a lot of challenges. The same is true with land-based transmission. It's just a different set of challenges.
Great. Thanks, Arnie. We have time for one more question. And basically in the East Coast, we've seen projects being procured in one of two mechanisms, either through a power purchase agreement or through an OREC structure, an offshore renewable energy certificate or credit. Given California's unique situation, particularly in light of PG&E's bankruptcy, as well as the proliferation of CCAs, community choice aggregators in California, what type of support scheme do we anticipate seeing developing in California for offshore wind? A PPA, an OREC, a feed-in tariff, hybrid version, something else? We've got about 2 minutes.
Well, let me start. We do not really expect too much of the support from the state. The state does not like to do carve-outs, and they seldom did, actually. So what we see is demand. Demand is there. CCAs are coming to us. In fact, last year, Castle Wind signed a memorandum of agreement with a community choice aggregator in Monterey because they do want offshore wind. So I'm not really expecting that there will be a problem selling power, but what they want is they want it sooner rather than later. So when we're looking at 5, 7 years, 10 years, we can't give them the date when the power could be available. And that would be even more of a challenge than finding demand. Demand is there. We know that because people want different resource than just solar and storage. That's already a given, but we need to be able to put the timeline and to project when can we really deliver power. But we are expected to compete on market basis in California. That is what the goal is, and that is what the requirements are.
Thank you. Jason, do you want to give us a quick comment on that question in the Oregon context? We got about 30 seconds left.
Well, I was actually thinking about it from the California perspective. I agree with all those comments. I think one of the interesting ideas that are floating out today is aggregation of demand. So if you have a number of smaller CCAs, might not individually be able to procure from a large wind project, but if you had a mechanism that allowed them to aggregate their demand, you could do so. Same way with some sort of centralized procurement for last resort. Would facilitate purchase of large wind projects. In Oregon, I think we've got some work to do here in the next year as we implement the governor's new executive order. That rulemaking process will be, in the details effort. We have a history of supporting offshore wind directly with something we call the Business Energy Tax Credit, the BETC here in Oregon, that drove about 5 gigawatts of terrestrial wind 10 years ago. I don't think we'll see that mechanism necessarily, but clearly there is interest in offshore wind, and over the next year we'll be leaning on some of these policy provisions that might help us move this sector forward soon.
Thank you very much. And we're going to have to leave it here for today. I'm sure we're going to continue this conversation in the future, and certainly in August in Providence at IPF Together. I'd like to thank once again our moderator, Chris Potter, as well as our panelists, Nessie, Jason, Arnie, Philip, Nancy, and Alla. We're excited to see how offshore wind development continues to progress in the Wild West. We'll be back at 12:30 Eastern with our final workshop for day one of IPF Virtual, Advancing Offshore Wind Resource Characterization Research at the U.S. Department of Energy. Stay tuned.
Bravo.
Thank you. Bye-bye.
Thanks.
Welcome back, everyone. And to those of you who are logging in for the first time today, thanks for joining us. Just a quick reminder that IPF Virtual is being recorded. A link to the recording and presentation slides will be sent to the email address that you used to register. If you have any questions for the panelists, please go ahead and type them into the chat box during the course of the presentation. If you are experiencing bandwidth issues, we would ask that you please refresh your browser. You may also want to close other programs that you're running on your computer, and to the extent that it's possible, ask the other people in your family to reduce the number of devices that are accessing your home internet connection, as that may free up some bandwidth for the IPF virtual broadcast. Finally, the network would also like to thank its IPF sponsors, specifically our 2020 host, the state of Rhode Island, and our IPF virtual partner, the law firm of Womble Dickinson. Now I'd like to introduce the speakers for today's final workshop, which is called Advancing Offshore Wind Research Characterization, Advancing Offshore Wind Resource Characterization Research at the U.S. Department of Energy. Please welcome our panelists, Dr. Alicia Gorton, Project Manager and Ocean Engineer in the Coastal Sciences Division at the Pacific Northwest National Laboratory, and Dr. William Shaw, a Wind Energy Program Manager at PNNL. Alicia, over to you.
Thank you. So thank you all for joining today and sticking with us through the last panel. My name is Alicia Gorton, and it's our pleasure today to present to you Advancing Offshore Wind Resource Characterization Research at the Department of Energy, where we're going to focus on DOE's investment in the LIDAR buoy program. All right, so we'll begin our discussion with some motivating factors and drivers for why DOE is investing in offshore wind resource characterization research. We'll provide an overview of the DOE LIDAR buoy program. We'll then discuss some previous, current, and future buoy activities, and we'll finish our formal discussion with a summary.
All right, thank you, Alicia. To provide a little bit of background, the Department of Energy aims to support the offshore wind industry through identifying barriers to development and then carrying out a program of research and development that benefits the entire industry. One of the ways that DOE gathers information about how to do this is through workshops that engage the industry and academia and federal laboratories. And in this vein, the Department of Energy carried out a workshop last March titled Research Needs for Offshore Wind Resource Characterization. The purpose of this workshop was to identify key knowledge gaps that can be effectively addressed by researchers currently. And the attendees, which were about 55, represented industry, researchers, consultants, government agencies. And again, the objective was to build on the National Wind Strategy and its update and other workshops that have been carried on before, but to provide DOE with a fresh view of what's currently needed to support the industry offshore. So the topics discussed range from industry requirements, engineering needs. Loads engineering has some unique challenges in the offshore environment, as everyone knows. And then we had a good look at the current state of offshore modeling and observations and the possibilities for information improvement. The outcome of the workshop, the information gathered, is informing DOE as they make decisions about potential R&D investments. And for those of you who might be interested, there is a workshop report that is downloadable from the Wind Energy Technologies Office at the Department of Energy. Next slide. In addition to the buoys that we'll be focusing on today, DOE has several parallel initiatives that they're supporting to advance offshore R&D. One is a just announced funding opportunity announcement. Came out on April 1st. And in particular, it's a two-topic FOA, but in particular, topic one is aimed at improving wind resource model physics for foundational wind forecasts and other applications in the offshore arena. This work that's envisioned in the FOA is actually an extension of two prior projects that DOE has collaborated with NOAA on, the Wind Forecast Improvement project initially in the US Midwest, and then the second wind forecast improvement project in the Columbia Basin. And so this really represents an extension of DOE's effort to the offshore arena. In addition, DOE supports the National Offshore Wind R&D Consortium, making an award to establish that to NYSERDA, which is the New York Energy Research and Development Authority. So there is a lot of work that's being supported by that consortium as well, with DOE assistance. Very recently, there was an award by NYSERDA to update the 2013 Wind Toolkit with an emphasis on offshore, and of course, public dissemination of modeled wind resource data will be an outcome of this. In addition, DOE has supported SVIR projects, and two that are ongoing at present that are potentially really exciting are a radar development effort by Helios. This would be a complementary platform that would use radar in a way analogous to LiDAR, but radar has some very attractive characteristics that complement LiDAR systems, particularly for R&D. Boulder Environmental Sciences and Technology is also working on what is called a marine profiling radiometer that would be buoy mountable and would provide profiles of temperature and humidity throughout the lower layer of the atmosphere. This is really key missing information from all platforms currently, and because of some of the configuration of the US is a particularly needed measurement. Back to you, Alicia.
Great. Great, thanks, Will. So to expand on the buoys a bit more, the objective of the buoy program is to facilitate met-ocean data collection using validated methods to support the development of standards to collect information needed by the US offshore wind industry. And you'll see a general high-level timeline here of the buoy program activities. So first, 2 Axis Wind Sentinel buoys were procured in 2014 and underwent acceptance testing at PNNL's Marine Sciences Laboratory in Sequim, Washington. And the buoys were then transported to the East Coast and deployed off the coast of Virginia and New Jersey between 2014 and 2017. In 2019, the buoys underwent several upgrades, including upgrades of their LiDAR systems, leading to a validation campaign this year that actually just wrapped up a few weeks ago. And next up, the buoys will be transported to California to be deployed in partnership with the Bureau of Ocean Energy Management, which Nessie mentioned in the previous panel. So as part of the overall buoy program, DOE has a buoy loan program that lends the buoys to qualified parties to acquire wind resource characterization and oceanographic data. And under the loan program, the buoys may be made available for loan for 12 or more months at a time. And during that time, the loan partners assume full responsibility of the buoy, and it's the expectation that the buoys are returned to PNNL in fully functional condition. And the loan partners must fund all buoy-related activities. DOE will not provide any funds to support the development. So PNNL has developed some program material for the buoy loan program that goes into all of the gory detail about the loan program and what the application process entails. And data access is a large part of the overall buoy program to ensure that all of the data is easily accessible to the offshore wind stakeholders. And so therefore, all of the data that's collected by the buoys, both the meteorological and the oceanographic data, is made publicly available. So the near real-time data that's collected during active deployments are available on the DOE LiDAR buoy data access page. And then the full raw data sets post-deployment are archived on the Atmosphere 2 Electrons, or A2E, data archive and portal. We have a LiDAR buoy webpage at PNNL, so you can find program material and data access information there, or you're welcome to contact either Will or myself for more information, and our contact information will be on the last slide. All right, so I'm sure you're all wondering what type of instrumentations are on the buoys anyway. So in terms of power, there's a wind turbine, there are solar panels, and there's a diesel generator inside one of the compartments to provide power to the buoy instruments. You'll also notice an antenna for satellite communications. For meteorological instrumentation, there are instruments and sensors to measure solar radiation, the wind profile, wind speed, and direction, air temperature, and relative humidity, and also barometric pressure. And on the oceanographic side, there are instruments to measure water velocity profile, seawater conductivity and temperature, wave spectrum information, and also sea surface temperature. So now we'll summarize some of the previous, current, and future buoy activities. So the maiden deployments for the buoys were off the coasts of New Jersey and Virginia between 2014 and 2017. We have some photos here of those. Both deployments were a success. However, there were some lessons learned. So first, there were some issues with biofouling on the conductivity probe, and moving forward, we acknowledge that additional maintenance and servicing of instruments may be needed. Second, we learned the value of redundancy of instrumentation. So one of the cup anemometers deteriorated on one of the buoys. So luckily, each buoy has 2 anemometers, which just demonstrated the value of redundant wind speed measurements. Third, this issue is currently ongoing, but part of the current record is suspect as a result of potential current profiler issues. We see some odd directional shifts in the current directions from both deployments, which are not present in either the wind or the wave records, which leads us to believe that those shifts in the current direction are actually an artifact of the current profiling instrument rather than natural shifts. And so this issue is still unresolved. However, the shifts could potentially be due to profiler beam interference or errors in data logging or onboard processing. And then finally, both deployments revealed limitations with the original LiDAR systems, and analysis of the LiDAR data from both buoys indicated that the laser power of the original Vindicator 3 LiDAR systems appeared to be low. And so this low laser power resulted in a low bias in the wind speeds during periods of low carrier to noise ratio, or CNR. And these findings highlighted the need to upgrade the Vindicator 3 LiDAR systems to more powerful systems. And now I'm going to pass it over to Will to talk a little bit more about the data analysis.
All right, so thank you, Alicia. And Alicia highlighted some of the lessons learned, but there are some very positive lessons that we've been able to learn. DOE has provided support to PNNL to carry out really a rather extensive analysis, scientific analysis, using the bulk of the data collected by the buoys. And that analysis has involved, as you might expect, a look at the annual and seasonal variability of hub height winds. This is after our LiDAR experts at PNNL process the data to eliminate the low bias, and so we use corrected data to get at these distributions. But we have done a variety of calculations and representations of the wind. You can see the wind speed distributions from the Virginia deployment under various stratification or stability conditions. So when the atmosphere is stable, which is the far right figure, wind shear tends to be quite a bit higher. And you can see on the right the stable conditions, in the middle unstable conditions, and then in the green on the left the in-between conditions. And so you can see that the stability classification results in a very different Weibull distribution, or a very different wind speed distribution, because of the physics of what's going on. We've also done an additional analysis of surface conditions, including the winds. We have used the core algorithm from the Woods Hole Oceanographic Institution to calculate turbulent fluxes or to estimate those from the Bloch method. We have examined the data on the basis of the temperature difference between the air and the ocean. We have also developed and applied a turbulence algorithm to these systems based on work that had previously been published, but we carried out an extensive evaluation of that. We have analyzed the wave conditions at both locations, including the two-dimensional wave spectra, and we've also carried out within the caveats that Alicia mentioned an analysis of the currents at the two deployment locations. So all of this is actually about to be published in a report that covers 2 years of this analysis. And that will be available on our website. There will be a link to it, and it will be available through OSCE, I expect, within the next couple of weeks. Back to you, Alicia.
Great, thanks, Will. So now we're going to take a look at current buoy activities, which includes the LiDAR upgrades. So as I previously mentioned, the East Coast deployments and subsequent data analysis highlighted the need to upgrade the LiDARs to more powerful systems. So as a result, we released a request for proposal in January of last year, of 2019, for qualified vendors to submit proposals for how to upgrade the LiDAR systems. And the LiDAR upgrade and validation contract was awarded to Ocean Tech Services, OTS, in May of last year. And during this past summer, OTS upgraded several buoy systems, including upgraded LiDAR systems, data logging systems, and data communication systems. And beginning in January of this year, the buoys have been deployed off Martha's Vineyard to be validated against a reference LiDAR on the Air-Sea Interaction Tower, or ACIT tower, that's maintained by Woods Hole Oceanographic Institute. And the validation was complete as of a few weeks ago. So the next steps are for DNVGL, who's the wind energy consultant that's overseeing and supervising the validation, for them to complete a validation test report and an independent certification to document that the LiDARs have been validated in compliance with Carbon Trust recommended practices.
So just a word about the outcome of this validation. You can see in the photo at the bottom, the Air-Sea Interaction Tower and the two buoys, each of which is about 500 meters from the tower, and they're about 500 meters from each other. One of the things that we required as part of the upgrade contracting for these buoys is that they be validated to the to be able to provide bankable data according to or in compliance with the Carbon Trust recommended practices. We have, or our contractor has engaged DNVGL as the certifying organization for that. And so this study was carried out, as Alicia said, at Woods Hole. It was carried out January through April and supervised by DNVGL. So on the right, I don't expect people to read the fine print, but we have some preliminary plots that were provided by DNVGL. The top row is for buoy 120, and the bottom row is for the other buoy, buoy 130, by our ID numbers. And you can see wind speed in the left column and wind direction in the right. And we're really quite excited about the performance of these systems. They were out in conditions that filled all the requisite wind speed bins. And through all of that, including some gales and hurricane force gusts, they returned an R-squared value of greater than 0.99 for each of the buoys, and a slope for both wind speed and direction that is statistically indistinguishable from 1. So we really feel like these systems have passed this validation test with flying colors. One of the other things that we're excited to be working on with this too, I mentioned earlier in the analyses that we did with the deployments off Virginia and New Jersey with the old LiDARs, the development of a turbulence algorithm. We are carrying that a little further forward. The system, the reference system that is on the ASIC, again, that you see in the photo, has already had some turbulence analysis done by Woods Hole and University of Colorado and others. And we are planning to use turbulence measurements from that and an acoustic anemometer that's also on the tower to really push the development of our ability to extract turbulence from these systems. And not only will we be getting turbulence in the sense of turbulence intensity, which is a variable of greatest interest in many cases to the wind industry, but we are looking at the possibilities for getting turbulence kinetic energy, what is known in atmospheric sciences as the stress tensor, which would really be an exciting thing if we could pull it out. We're not sure we can do that, but that's part of our future research. So in summary, on this slide, we have, I think, a really excitingly successful validation, and we're looking forward both to supporting the wind industry offshore with measurements, but also doing some really cool science with it.
Great, thanks, Will. So what's next? So now that the LiDAR validation is complete, the buoys will be recovered and transported to California to be deployed off the north and central coast in partnership with the Bureau of Ocean Energy Management to provide wind resource characterization and expanded model validation. The buoys will be deployed in the summer of this year and will be deployed for 12 months at each location. So the buoys will be deployed in parallel. All of the data that's collected during these deployments will be made publicly available on the A2E data archive and portal. And then the deployment off the north coast will include an additional environmental monitoring study that is funded by the Department of Energy in the form of bird and bat monitoring using a thermal stereo vision technology called Thermal Tracker that has been developed by PNNL. And this technology is used to characterize flight tracks of birds and bats and will help us understand more about bird and bat presence and behavior offshore. So in summary, the Department of Energy is supporting several initiatives through their offshore wind resource characterization program, which is supporting the offshore wind industry by identifying research needs for offshore wind resource evaluation. And this includes identifying met-ocean information needs, key science challenges, and information resources to advance the science. And to that end, DOE is investing in wind resource characterization and technology demonstration projects to improve the ability to forecast energy production and demonstrate innovative data collection technologies not yet developed at the commercial scale. And thanks to the investments by DOE and others, such as BOEM, through the deployment collaboration, the LiDAR buoy program is advancing, and it's going to support met-ocean data collection using validated methods. And just to quickly recap the progress of the LiDAR buoy program to date, the buoys underwent upgrades in 2019, including upgraded LiDAR systems that were validated in compliance with Carbon Trust recommended practices this year. They're going to be deployed off the California coast in partnership with BOEM beginning this summer through the summer of 2021. And then finally, the buoys will be part of an East Coast offshore wind resource science study through 2025 as part of a DOE R&D focus on large-scale modeling and observation. So with that, I'd like to thank you all for sticking around. The contact information for Will and myself is provided here if you'd like to reach out to us to learn more about the buoys, to receive the technical report that Will was talking about related to the data analysis from the East Coast deployments. If you're interested in program material and data access information, we'd really like to thank our sponsors and our subcontractors for enabling the success of this program. To our sponsors, DOE, the overall sponsor of the LiDAR buoy program, and also to BOEM, who is partnering on the California deployments, and a big thanks to our two main subcontractors, Ocean Tech Services and Axis Technologies. Thank you.
Thank you, Alicia and Will, for sharing these insights. We'll now be taking some questions from the audience. If you haven't done so already, please go ahead and type your questions into the chat box on your screen. You may need to refresh your page to enter some questions into the chat box. So, Alicia and Will, one question that I had, could you provide some more detail about the technical specifications that were required for the buoy upgrade? And can you also tell us more about the LiDAR systems that were ultimately selected?
Sure. Well, to begin with the LiDAR systems, these are the Leosphere 866 V2 systems that are designed for marine use. They've been around for a while, and they are the LiDAR system that satisfactorily met our criteria. So in getting to our criteria, we really had two customers in mind, if you will. The first is that the buoys really need to be usable for resource assessment by industry, so that we wanted the data to be satisfactory from an industry perspective for resource assessment purposes. But the other purpose for these buoys, and it's a significant purpose as well, is that the buoys need to provide data to support improving our understanding of the physics of the marine environment, so that we can produce better models for forecasting and for other purposes. So for the first application, we needed LiDARs that would be powerful enough to cover the existing rotor layers, but also to be able to reach high enough or as high as possible, given the anticipated increasing size and actually increasing size of wind turbines that's currently being realized. And along that line, and to make sure that they are in fact usable by industry for resource assessment, we wanted to make sure that they were validated to or validatable to Carbon Trust recommended practice standards for stage 2, which is the level for bankable data. For the scientific applications, though, we wanted a little bit more than what industry requires from these systems. We need to be able to get our hands on relatively low-level data. So we needed to be able to get access to individual beam average returns, not just 10-second return or 10-minute returns or 10-minute averages, but 1-second LiDAR beam data needed to be recorded, and we needed to have access. We also needed to have access for other low-level data, such as the carrier-to-noise ratio that Alicia mentioned. So we needed to go with a LiDAR that whose vendor would be willing to or comfortable sharing that in a research environment. And so that's really what led us to these systems.
Alicia, did you want to add to that?
No, that I think Will covered everything. That's great, Will.
One question that I had, how are the siting decisions made for these buoys? What factors determine whether a particularly selected buoy location is capturing a representative sample?
Well, getting a representative sample can actually be a tricky thing because representative is a concept that doesn't always apply. I think it's well known that the wind field can vary significantly even across the size of a single wind plant, particularly on land, but sometimes in coastal circulations as well. But recognizing that one may not have or be able to identify a perfectly representative site, a site that is likely to be very useful is one that is very close to a Bowen lease lock. And so we wound up deploying the buoys off Virginia and New Jersey just at the edges of the Virginia call area and the call area off New Jersey. And that was basically how we selected that. Not a great scientific motivation by itself, but the idea is that we could do some really good science in those locations. And by the way, it would be very close to a place that would be relevant for wind turbines.
Yeah, and I can expand on that more for the California side. So there's a lot of coordination and planning between PNNL and BOEM. We worked really closely to select the deployment locations off the north and central coasts. Specifically, we looked at offshore wind speed information that came from models from NREL, We looked at oceanographic information such as wave heights and currents from buoys in the area and also from some local oceanographic models. We looked at the water depth, we looked at the bottom type, and then we also looked at vessel traffic information. We looked at competing ocean uses and also sensitive species habitat.
Great, thank you. This is a little bit beyond the buoy question, but do you see the use of autonomous vehicles as a next step in conducting wind measurements? What are the advantages of such a system?
We talked, oh, sorry, go ahead, Will. I guess I can go from the oceanographic side. We have talked about using ROVs to perform some of the maintenance and servicing, to use them and deploy them to see if there's any derelict fishing gear that gets caught in the mooring system. So that's being talked about. But then also as a separate monitoring system that could be integrated with the buoy as well. We've thrown around ideas about integrating an ROV or an AUV to collect water quality information and collect water samples. We haven't pursued that further, but we have started those conversations, and I can let Will talk about it more from the atmospheric side.
Sure. I think autonomous vehicles, drones, if you will, have some real attractions, and the technology has gotten to the point where there could be some real utility in using them. One of the things that has historically been done in the marine environment is to carry out process studies, because doing science in the salt air and the way the environment is risky. It's a hostile environment. It wreaks havoc on equipment, and it's very expensive as a result. And so process studies have typically taken several weeks or maybe a couple of months for really big ones. And remotely piloted vehicles or autonomous vehicles, can be particularly useful if you want to make intensive measurements and to look at processes. But they have also advanced. The Office of Science in their climate science program is already through their what they call their ARM aerial facility, using or developing unmanned aerial systems that can go over the horizon, can be autonomously controlled. And of course, all of this has to be done in conjunction with the FAA. But really, for wind energy, one needs to get a good look at what the atmosphere is doing, not just under conditions that illustrate a particular process, but through the whole spectrum of conditions that occur throughout the year. So I think we're getting to a point where I could envision a significant contribution from these systems. I think it will be quite a while before they would replace on-station systems like buoys or towers or things that can be out all year.
Thanks, Will. Now back to the buoys question, or the buoys issue. Are these buoys capturing only wind data, or are they also capturing other metocean data, wind, wave, currents, salinity, and what data is being captured by these buoys that we've been discussing?
Yeah, so the buoys do have both met and ocean instrumentation. We have the LiDARs to get the wind velocity profile. We have anemometers for wind speed and direction. We also have sensors for solar radiation and atmospheric temperature. We also have on the oceanographic side, we have an ADCP to get the water velocity profile. We have a wave sensor to get wave directional information, sea surface temperature, and conductivity.
Yeah, so if I could just add, the current profiler currently has a range of 90 meters depth. It is possible to switch out current profilers that can go much deeper depending on needs. But the current profile, the application there could certainly be for looking at problems of scour. One of the things that we really wanted in these systems from the very beginning was the ability to get some real physics insight into the air-sea interaction processes that are going on. And so, as Alicia mentioned, we have a rather complete set of data that allows us to get some key oceanographic information, to get the estimates of the heat and water vapor and momentum transfer or friction of the atmosphere on the surface, and to use that information to understand why the shape of the wind profile is what it is under a given set of conditions.
Great, thank you. Can you comment on how the data recovered by these buoys compares or does not compare with data from existing wind farms in the North Sea? More specifically, how do the predictions from the buoys compare to actual facility performance?
So we have not actually compared, because these buoys have never been deployed beside facilities, only beside areas that will someday, we hope, have facilities. We can't really address that as an outcome. And I can't, other than knowing that or showing the validation results and showing that the buoys do as, I think, as good, or some can argue better because you don't have flow distortion around the beams, as good or better a job of getting the wind profile as, say, a tower. I think that that these provide really excellent information from being able to infer what the likely power production in a particular area would be. One thing that I might add to that is that it's not possible to directly extrapolate what goes on in Europe to the conditions in the US, however, because we do have some unique conditions. Off the West Coast, to start there, there's a very long ocean fetch that generates, and very strong storms that occur in the Pacific that generate, and the deep water and the continental shelf structure generate really large or heavy sea conditions. And so the atmospheric structure there, with the upwelling that goes on from the deep water and the stable stratification that occurs, is really different from what they find off the west coast of Europe. On the east coast of the US, we also have some novel complications. The sea breezes, of course, happen everywhere in the world, but we also have a Gulf Stream. And the variation in water temperature from the shore out over the Gulf Stream generates some fairly complicated circulations, including frequent low-level jets that we and others have observed. And so I think having the buoys making measurements in US waters is really important, because some of the phenomena that dominate the wind structure here are really quite different from the European experience.
So for those of us who are not familiar with the Carbon Trust, could you explain the significance of their guidelines with respect to gathering of mid-ocean data in the United States?
Sure. They developed what is known as the Offshore Wind Accelerator, and I expect many in the audience have a much more intimate experience with that than I do. But as part of their effort to reduce the cost of wind energy, ultimately, they were very supportive of the development of LiDAR buoys as an alternative to very expensive meteorological towers. And they also recognized that at the outset of the development of LiDAR buoys, there really weren't standards, there weren't recommended practices that would make financing organizations feel comfortable in using the data in lieu of a tower. And so one of the services that they provided was to develop a set of recommended practices to guide the use of these systems. Those have also now been incorporated, or being incorporated in IEC standards, I believe. And so that really is how the Carbon Trust came to play a substantial role. It was an effort to find a lower cost way of getting bankable information to accelerate the development of wind energy in Europe. And we're benefiting from their experience and their expression of those practices.
We have a question here requesting that you give some more detail about the thermal tracker stereo vision technology.
Sure, I could talk a little bit more about it. So it's actually an open source software. So if you Google thermal tracker, you can actually find the software for it, and you can use it on any desktop or laptop computer. But it was developed at PNNL, and it quantifies the flight tracks of birds and bats by the time of day, the direction of travel, the relative size of the animal, based on thermal imagery. And combined with other information that you can feed into the software, you could even potentially identify species. So the PI of this work is from PNNL. They've done some field tests of the thermal tracker at our Marine Sciences Laboratory and also at NREL at their National Wind Technology Center there in Colorado. We actually have a camera on one of the buoys that's deployed off of Massachusetts right now. It's kind of a testing camera in preparation for the deployment off the coast of California. And when we integrate thermal tracker with the buoy for California, we're also going to be working with H.T. Harvey, who's kind of an ecological environmental consulting firm. And we're going to be pairing the flight tracks of the birds and bats that we record using the thermal tracker to actual seabird observations from a vessel in the vicinity of the buoys. So that'll make for a nice research study. And if you're interested in more information on thermal tracker, you can feel free to shoot me an email. I can pass you along the contact information of the PI from PNNL, or as I said, you can just type it into Google and you can see some of the open source information as well.
Great, thank you.
I might add to that, that I think are really cool is that we're doing we, PNNL, Sherry Master in particular, is doing a stereo vision or stereo camera approach to this so that you can get range of the species. And one of the really exciting outcomes of this, I think, is the possibility for reducing the need for humans to manually count birds and bats. But this system can do that at day or night, 24 hours a day. And we hope will provide not only a more comprehensive, but perhaps even a more accurate assessment of the avian life.
Wonderful, thank you. I have a couple more questions here. One question says, have you compared the data from these collected by these buoys to NREL's resource maps?
We have not done that yet. I think NREL may be doing that, actually. And I'm sure, as a matter of fact, I'm sure they will be as part of this updating of the Wind Toolkit. We, in fact, as part of the research that we're doing, a little bit more detail of what we're carrying out, we have been looking at reanalysis data where various models that are used by the community are updated with all available data to provide the most accurate fields possible. It turns out that the reanalysis data sets were developed before our buoys were put out. So we have a great independent comparison where they didn't have data to see how they're doing. And so we're using reanalysis data sets offshore to compare with the wind measurements that we've made and other measurements to see if these models are really struggling in any particular areas that we might be able to improve.
So I have a pretty general question that came in. How do you envision the data that's collected by these buoys will help in the development and management of U.S. offshore wind facilities?
Shall I take that, Alicia?
Well, I mean, I do know, especially on the West Coast, we're deploying the buoys in partnership with BOEM. So I do know, obviously, the data will be made publicly available. So all of the developers that are potentially interested in the lease areas, once they're open for lease, will have all of that information publicly available, and anyone else as well. Will, do you want to add to that?
Well, just a couple of things. One is I think that having the data offshore and the data publicly available ahead of the issuance of leases will certainly help BOEM accurately value the leases. And I think that's important for the development of wind energy in the US in general. And the other, in addition to providing perhaps assessment data that would be useful to particular interests here or there, that the data may will also lead to the improvement of our ability to model the wind offshore. And if we can improve the physics using data from these systems, of the numerical models that we use, we can improve the forecasting, we can improve the assessment, not just for the data were collected, but in the entire offshore arena.
Great, thank you. In your data analysis, how did you determine the local atmospheric stability? How was the temperature profile determined?
So the method that we used is known as the bulk method in boundary layer meteorology. And it uses a theory called Mononobekov's similarity theory, which is a set of equations that will tell you the shape of wind and temperature and humidity profiles if you know what the surface turbulent fluxes of heat and heat and friction and water vapor are. And so it turns out that this bulk method, as they call it, and the implementation that we use is known as the core algorithm from the Woods Hole Oceanographic Institution. But the algorithm that we used will take things like the water temperature and the air temperature just above the water and the wind speed just above the water that we get from the cup anemometers and other basic information like that, and look at the differences in the vertical over known heights like 4 meters or 4.3 meters on the buoy. And you can take that information and use iterative techniques to solve these equations and to get the turbulent fluxes. Once you have that, then you can use these to get a profile. But then, of course, for the wind profile, we have points of measurement from the surface or near the surface up to above hub height of anticipated wind turbines. So we can measure the wind profile. For things like temperature and humidity profiles, we can estimate them from this bulk technique.
Great. And just sort of a general question, these buoys that we're looking at on the screen here, can you give us an idea how big they are, how long they are, how tall they are?
Sure. I like to say when I explain to people that to me, kind of a small school bus almost. They're pretty large. Trying to think off the top of my head what the exact dimensions are. I want to say maybe they're 12 feet long, 6 feet wide.
It's actually 20 feet.
20 feet, so 20 feet long, maybe a little bit more than 6 feet wide.
Mm-hmm.
So they're pretty big.
Great. Okay, I have one more question for you here. When inputting the LiDAR measurements into forecast models, how frequently does the data inform the model? How do you retrieve the data via FTP, HTTPS, something else? And what is the duration of time from LiDAR measurement to the output of the forecast model?
Wow, that's quite a set of questions.
Yeah.
So as they are currently configured, the LiDAR data have not been ingested directly into the forecast models. So there are several ways of doing it. If we were sharing, and we do share the data with NOAA, if NOAA were ingesting this into their forecast models, they would be taking in the profiles along with the wind profiles and other information, along with all of the other information they use from weather balloons, from surface meteorological measurements across the country. And they put all of that together in an integrated data set that they then ingest into their forecast models. And I think, so I'm not a modeler, but I will, I believe that it's the rapid refresh that they do for NOAA is like every 3 hours that they would ingest the data. If one were trying to do a hindcast and wanted to anchor it with these data, then there are a number of data assimilation techniques ranging from nudging to variational analysis and you can basically feed in the wind profiles as often as you like. I think that the 10-minute standard profile would be probably ideal for using. It may be that updating would be done for some of these models for the larger scale a little bit less frequently, but that would be an offline kind of calculation rather than in forecast mode.
Great. Well, I'd like to thank you one more time, Alicia and Will, for joining us. We really appreciate you taking the time to come share your insights about offshore wind resource characterization. We're going to leave it there for today with this panel. So thanks for joining us.
Thank you.
Thank you very much.
Well, everyone, we really hope that you enjoyed today's program. Be sure to tune in tomorrow at 10 a.m. Eastern for IPF Virtual Day 2, where we will continue to bring you the time-sensitive insights that you need to plan your business in the rapidly developing U.S. offshore wind market. So before we sign off for today, I have a couple of closing reminders, updates, and comments. First, tomorrow is the 50th anniversary of Earth Day. Second, I have a few upcoming events that we would like to make you aware of. On April 30th, the Global Wind Energy Council and Global Wind Organization will be hosting a webinar titled Webcast on Wind, Powering the Future. For more information on how to register, please visit one of their respective websites or the Business Network for Offshore Wind's website. Later this spring, the network will be taking Pitch and Brew virtual. Pitch and Brews are 2 to 3 minute business services pitches that the network has held at our live events in the past. We've decided to bring them to you virtually until we can be together in Providence in August. This is a great marketing and business development tool, so please let us know if you're interested, and we'll be sure to get you on one of the first rounds with the other Pitch and Brew companies. And last but not least, IPF Together will be held on August 18th to 21st in Providence, Rhode Island. We can't wait to see you there. And we don't need to be physically together to connect. You can do that right now through the Business Network's program called WindMatch. This connection tool is open to members now and will be open to non-members on May 1st. Starting on May 15th, you can set up meetings using any virtual platform that you'd like. Zoom, Skype, Teams, over the phone, whatever the case may be. So you can go ahead and start virtually connecting until August 18th, when we can elbow bump on site in Providence and share a drink together. We'll see you back here tomorrow at 9 a.m. Eastern. From all of us at the Business Network for Offshore Wind, enjoy your day.